Everybody to the second themed webinar to support the ISCF Future Flight competition. So this is obviously the second one. Today's theme is use cases, and the aim of these events is to help inform you of new knowledge and enable new collaborations into phase 2 of the competition. To aid that, can I suggest that all of you that are phase 1 successful applicants introduce yourself in the chat function, who you are, excuse me, what you are working on, just to help get that conversation started. So you can use you can post questions in the chat box, and my colleague Simon Buckley is with you to help monitor those questions. And we will pose those questions to our speakers during the Q&A break, Q&A session, which is at 11:50. So you are all live on YouTube. This means the event and all other Future Flight events are stored there for anyone to view. So just in terms of the agenda today, if you're expecting Logan, unfortunately, Kieran was been taken ill, so it's gone through a few iterations, I must admit. But we've got a very good lineup today, and I'm very pleased that Nick and Jack have stepped in at the last minute. So I'm very, very grateful for that. And it's a particularly challenging time for people for a whole suite of reasons, and illness seems to be a prevalent one at the moment. So I just want to thank you all for your interest, maintaining interest in Future Flight. I think that's a really, really positive thing to see, and just wish everybody a speedy recovery as well. So we just pass over to Gary Cutts, who will start today's session. So when you're ready, Gary.
Thank you, Michelle, and I shall wait with bated breath to check I've got control. I would try to add my thanks to all of you this morning. For any of you who joined the last session we had on infrastructure, I'm afraid you're going to hear about 20 minutes of largely the same speech, because we're trying to just give the same introduction to all of these, with a little bit of extra context in here. And as I say, I'd like to add my thanks to you. I think we feel somewhat humbled by the amount of interest we have in this area. KTN over the last year have built a large network of people, but when we've had previous networking events, we seem to settle out at about 150 odd people of interest. I think this time, from memory, we have more than 200 people registered. And from our experience last time, which was really positive, the number of people who arrived on YouTube was significantly higher than that. So, you know, we could be talking to many hundreds of people this morning. We're really grateful for your continued interest. We do know that these are really difficult and challenging times for everyone. The temptation to go off and put our attention onto other things is extreme, and therefore you keeping your attention on Future Flight is a really important thing. And I would stress that from our point of view, much as COVID-19 will present challenges to the programme, we think that the underlying case for developing this next generation of aviation remains strong, and the government remains committed to it. So let me walk you through where we are. The first intent is just to give you a little bit of an update on where the challenge itself is. Then I'll run through what the challenge is all about. So first, the mechanics. The phase 2 competition was intended to open on the 6th of April, a date we set quite a long time ago. That's slid back by approximately 1 month now. We're thinking the most likely is 5 weeks. And I want to stress that's for internal operational reasons. There are 3 reasons why it just became inevitable we had to take a small slide. Number 1, obviously, all of our operations staff are now working remotely. They're not in the office. We have our own issues, of course, with sickness and absence because of the current crisis. People have childcare and so on. So our efficiency is somewhat down in that area. I think the team are working incredibly hard to keep things operational, but that was a challenge. The second one, a little bigger, is of the existing programs across UK research and innovation, of which there are many billions of funds that we put out there, a number of people in there need to have changes now. Their business has changed remarkably. So if you think of something as simple as We fund an awful lot of research through universities. In essence, most university research in physical labs has now stopped. So there's a ton of change requests going through operations. And the third, and I would say probably the most important right now, is that we've seen the appetite and desire for the research and innovation communities to do things that directly help with fighting COVID-19 is just enormous. So the amount of people coming into us looking for support to do innovation in that space is significant. And we've quite rightly prioritised through operations those new competitions that are trying to help with COVID-19, all of which made us take a 1 month delay. I'll stress again, we've taken no decision to change the direction or impetus or intent of the programme. We remain committed to it. The dates for phase 2, when we finalise them, will come out through KTN and all the usual social media platforms, but for planning assumptions, assume probably 5 weeks after the 6th of June, but to be ratified. So that's where we are on operational stuff. However, we come back, as I said, our intent remains unchanged. We remain completely passionate about the economic benefits, the social good of this new and exciting phase of aviation. And we said right at the start, if phase 1 of aviation, the first revolution, was getting airborne back in the early 1900s, and phase 2 was the jet age of longer haul, very reliable mass transit, then for us the third revolution is this flexibility and flexing how we fly, new classes of vehicles, new ways of transporting people and goods, and frankly a whole new range of services as well that we think are really important in transforming society. So that's where we are, and our passion remains unchanged on that. So what I'm going to do is just walk round. I think almost everyone will have seen the next couple of slides, but just for anyone who's coming into this fresh, what is Future Flight all about, and what's the shape of the programme that we're running? So we talked about vehicles before. There are a large number of different types of new air vehicles which are starting to come to the market. Fantastically interesting and stimulating time. And we talk a lot about 3 classes of vehicles. There are others. The 3 classes of vehicles that we often focus on and we socialise in Future Flight are drones. So some of my colleagues have said we're talking drones, industrial drones, not drones toys. There being a distinction. So significant drones. The drones are, they're present, they exist. The technology to make them fly and do challenging, interesting missions exists. We would contend that the infrastructure, the systems around aviation that allow them to be used for much wider use cases, those systems are not yet in place, but the vehicles are there at pace and developing. Second class of vehicle is air mobility. And air mobility, it's more like the thing that was on the slide that Michelle showed at the start. So if you think something like 3 to 5 person people carrying vehicles, possibly piloted, could be autonomous, or for us have to be a low carbon or zero carbon fuel source, so typically electric, but could be hybrid electric or hydrogen fuel cell powered. But the intent of these is that they are typically short range, pick up, put down people and or goods in short range places. People talk a lot about urban air mobility. That's not the only use case. We're really interested in the use of rural and journeys into cities as well. So they're quite different to drones. For those who are on the call and know all about this, you'll be unsurprised, but that market is incredibly active. There are more than 200 companies in the world developing those vehicles. We'd have to say that some of them perhaps won't make it. Some are very advanced, very technologically capable and incredibly credible. The vehicles are coming. The last class of vehicle for us is the sub-regional, more like a classic aircraft, but transitioned to be zero carbon power, hydrogen or electric. And for us, all of those classes of vehicles, the central thing is that the vehicle technologies are moving apace, but that if our vision of all of those classes of vehicles and others come into being, then the aviation system has to go through a radical transformation. It has to be subject to the same revolution as the air vehicles themselves. And that the aviation system, there has not been such a significant coordinated plan to make that transformation. So we're looking at everything that's on this chart. So first, the control and regulation. So what are the standards that allow these aircraft to fly? What are the standards that let them get airborne and be certificated themselves? but what are the standards around operation, around maintenance? What are the standards that allow them to fly in close proximity in cities? That's really important. Closely coupled with that is the air traffic management system. So today, the large air traffic management system, if I can call it that, in the UK, particularly in the southeast of England, is essentially full. We peak out at something like 8,500 movements a day, and it's full. We then have this wonderful vision to put thousands of air mobility vehicles into the same skies. Many of us think that eventually we want drones to be able to fly in the same airspace and not be segregated as they are today. So really obvious that there's a transformation in the air traffic management systems, and it's not an evolution of what we have today, it's a new innovation solution. We then think that there's a set of infrastructure requirements to come, and the infrastructure is the physical, and again, just a couple of examples. If you believe in the concept of urban air mobility, and it will happen, what does an airport look like that sits atop a building downtown in a major city? What's the fire regulation standards? How do you build that? What are the building standards? So there is a lot of innovation to let us be able to deal with that. We then talk a lot about the underpinning digital infrastructure, the way that these systems can talk to each other with security, with cyber security, and absolutely single source of truth, data precision. So there's a whole bit of infrastructure there. We know that the aircraft and aircraft technologies are a significant part of this as well. So although Future Flight is not looking to fund directly aircraft as such, there are aircraft technologies that need to be created to allow you to operate in this new aviation system of the future. And then lastly, and it's the place I'm finishing on because it's today's focus, is what we call the new operating models. Now, new operating models involves lots of things in there. It definitely involves this social acceptance. So can we get the public to the point where they're as excited as us in the industry are, and they want this, they see the benefits, and they want to see pull rather than it's being pushed towards them. So social acceptance is really important. And then this concept of economic models, business models, and use cases. Now, the use cases, that's really closely tied to this public acceptance. If the public can see that what we're doing, it has utility to them, it's important, they believe in it, it makes life easier, better, simpler, cheaper, that's really important. So in Future Flight, demonstrating meaningful use cases is really important to us. So the second heavy slide, and I should have said at that point a couple of things. So Future Flight is absolutely about that total integrated aviation system and systems that allows these new classes of vehicles to come into being. It is not about the vehicle, it's about the system. And secondly, we believe that they are codependent. So we cannot just farm out requirements and people develop infrastructure, digital infrastructure and vehicles. They're utterly tied together. So what we're looking to do is form consortia that work across those pillars and boundaries to develop this new aviation system. So in terms of phasing for the programme, I won't spend long on this, but we've always said that Future Flight, it's not deterministic. None of us, as smart as some of you are, can say what the endpoint will be in 24, 28 or 2032. We know we're developing new markets with a range of new technologies. The way that will shake out will evolve around us. So we've always shaped the programme to say we have this kind of funneling concept. Early on, we have a competition in discovery to understand what the concepts are out there, to bring people on board and to form consortia. We then move to phase 2, this development, where we're starting to have co-investment in innovations, and we will look to people to form consortia across boundaries, but we'll probably run with a number of consortia, in some ways with competing technologies. Then there'll be a down select in the final phase, where we're looking to do significant total aviation system demonstrations. And it's always been in our mind that we'll keep bringing people together. So it may be we end up with a couple of competing consortia in phase 2. They've got slightly different ideas. In phase 3, rather than one of them falling by the wayside, they come together. They form bigger, more integrated consortia that drives the industry forward. Our vision's always been that by the end of the challenge, we'll have demonstrated at least 3 classes of new types of air vehicles flying in a fully integrated aviation system, integrated with the existing aviation system, and the phrase I probably use more than any other, and undertaking meaningful, challenging use case demonstrations. We're not looking for people to do a kind of tethered flight demonstration in a rural field somewhere that proves you can fly and you can be safe. We're looking to do something meaningful, be very visible, very public, and it's a difficult use case, hence the point of today's conversation. So just to run through the research themes for phase 2. For those of you who were at the networking events, which were the workshops, I should say, really, which were the culmination of phase 1 of this challenge, we were quite open-minded. We said we had a number of research themes in mind, but we engaged with the community to develop, and that led us to extending the range of research themes. So the stuff that's now in phase 2 is the following. Covered a number of these, and I won't labour them. So firstly, the air traffic management and the unmanned traffic management systems, or the integration of those two. I've said we need to develop significant stuff there. The physical infrastructure concept and the digital infrastructure, which might be the software platforms and the data architecture that lies behind it. Autonomy. I've covered electrification a few times, but we've always said there are a number of intertwining technology capabilities coming to the fore. The other is autonomy. I think many of us believe that our vision of this future flight regime will be enabled partly by autonomy. And that might be in the piloting, it might be in the air traffic management, but the use of autonomous systems is important. So people have innovations and technologies there. Then we have the digital and the communication systems. It is self-evident that if we're going to put thousands more vehicles flying in closer proximity to each other and physical infrastructure, the way they talk to each other, that the joint decision making has to be pristine. So what are the systems let us do that? I touched briefly on the concept of new business models. What are the ways of going to market, but particularly what are the use cases we haven't thought of yet? What are the ways in which you get benefits from society? So we've found a number of really interesting use cases and potential business models. I think there's more to come. I touched on public acceptance. That's really important. Aviation is seen in many different ways. There is not one public, there are many publics, from the people who frequent air shows and will just love this vision that we are putting forward, to people who are tech driven and love the vision from a tech point of view, to people who don't fly and see this as intrusive. So that whole public acceptance piece is important. We're also interested in anyone coming forward with more integrated multimodal concepts. How would you make an aviation system work with, say, an autonomous land-based vehicle system to have end-to-end logistics? We see that simulation is an important theme too. We will not be able to do a full physical demonstration of thousands of vehicles. We'll do some limited demonstration. We and the rest of the world, I should say, will do limited physical demonstration. We'll want to simulate how that would scale up. We've added a few more things in here. So one, the area of non-aerospace regulation, and regulation will be the topic of our final, for now, engagement event next week. There's a lot of regulation which is not the aviation or aerospace regulation. We need to understand that. I talked a lot before about the use cases, so that's an area we're looking for people to bring challenging use cases into the challenge. And lastly, the total security systems. And just to finish off, we understand that people will be working on something else. As I said before, future flight is not deterministic. We don't fully understand the end point. Therefore, there will be people on this call who are working on something they don't see on that list they think is vital. We keep trying to write our calls so they say, these are the things we think are important. We point you towards them, but if there's something else you think fits, come and bid it to us. We're looking for that breadth of thinking. We will be looking for people ideally to work across those boundaries. Last thing, and this is something we created at the consortium networking event. We said we think there are also some underpinning capabilities that could be addressed rather by a consortia. One is this concept of a network of test facilities, which could be physical test or demonstration by digital simulation. Could the UK create this network of test facilities, again, not for the vehicles per se, but for the aviation system? Secondly, what is the underpinning data infrastructure that lets all these disparate technologies talk to each other, share models and data to work together? And lastly, going hand in hand with that, this concept of digital twin, which is our ability to do through life simulation of every aspect of the system and model how it works together. So they're three underpinning capabilities that we could look to get in the bids. So that's future flight, that's where we are. Our ambition remains the same. We're going to go through some challenging times. COVID-19 will affect us. It'll affect us in several ways. It will affect us in that we will look actively for things that can be done with future flight, can be accelerated to help with this new normal we have, but also we know it will affect people's investment plans and their appetite. It may well, and we see signs of this, accelerate some people's view that there's now a trigger for the world to change more quickly. And it's a great time to be looking at some of these future technologies. So just to give you kind of a minute on today's event and why it really matters. Use cases, and again, this is really important to us. I'm going to repeat what I said before. What we don't want to do is be a pure technology program. So we get to the end, 3 to 4 years hence, and we've demonstrated some really cool wow technology that just amazes people. And then we start to work out how on earth you might use it. We see this is technology that has to be developed with the user in mind, with the user engaged all the way through. So what we're really looking for is every consortium that forms to have somebody in it with a really challenging use case that creates that pull and creates the human interaction with the technology. So by the end of the challenge, the public will have seen things being done that the public believes in, and it gives a real acceleration to future flight. So I'll just end with, again, a thank you. We appreciate your time today. I think it's going to be a fantastic event. KTN's record of running these is just excellent. We have lots of good interchange, and it will still work online as well as this face-to-face. So with that, thank you, and I'll hand back to Michelle.
That's great. Thank you, Gary, for the positive feedback. You can come again. So, very grateful that Nick Anand from the AV project has kindly stepped in and is going to talk about launching aerial mobility in the UK. So when you're ready, Nick.
There we go, unmuted. Can everyone hear me?
Yes, we can hear you.
Brilliant. Thank you, Michelle, and thank you, Gary, for the introduction. I'd like to thank the whole team for making sure this event happens still, given the challenging circumstances. But moving on from there, I wanted to note, first and foremost, that it really seems that the world is changing around us right now. We're entering a new era that could very well be defined by a reduction in mobility demand and increased isolation. I mean, at the moment, we're seeing one of the biggest downturns in the history of commercial aviation. And I feel like we can't really rely on conventional wisdom anymore going forwards into this new era. In particular, a lot of us have been looking at business aviation as one of the main markets that we want to be targeting. But businesses around the world, in a matter of weeks, have changed how they operate and have moved to reduce or completely eliminate the need for travel. So more than ever, it's actually crucial for us to identify use cases that people really need instead of just creating luxury services that only work for very small markets. With that in mind, let me give a quick introduction to myself and the rest of the team at the Avery Project. My name is Nick. I'm one of the founding partners. I've been building multi-rotors and tilt-rotor UAVs for about 6 or 7 years now. I founded my own drone delivery company called Hermes Aerospace, which was funded in 2016. But in 2018, we actually realized there were no collaborative environments within this new emerging aerial mobility industry. To address that, I co-founded the Avery Project with Damien Kisley and Pamir Sevencel, who both have backgrounds in infrastructure and UTM respectively. And the mission was to launch the UK ecosystem and bring the industry together for the first time. As a result, we actually hosted the first ever UAM conference in the UK in late 2018. We had a variety of attendees and were able to have some roundtables as well as some public speeches later on. But one of the things that we noticed was that everyone still had a very different idea of what UAM should actually look like and how it should be done. In part, this is probably because a lot of the work in the space has been quite technology driven as opposed to market driven. We're still in a period where teams are trying to develop these new aircraft and see what they're capable of. But similar to the early days of flight, the ideal commercial models are still yet to be developed. In particular, it's still unclear what the optimal routes may be and how profitable they can be, if at all. So, to address this, we have started working on a range of international projects to understand some of the key market requirements and help shape the development of UAM operations. A lot of our work has been focused on the UK, but specifically, we want to be looking about how public perception will influence and also be influenced by the various different use cases. Before we can get onto that, though, we need to get to the root of these issues. We really want to focus on the question, why? When there are so many other different options, why use UAM? I mean, the goal is obviously to reduce the amount of time from A to B, but I believe that lengthy travel times are not actually the problem themselves, rather they are the symptom. Most of this industry actually seems to be driven by the very American vision, which is getting over blocked highways and cutting through huge amounts of congestion on the roads. But ground transportation in the US is really different from the UK. Theirs tends to be more road focused, and we actually have much higher densities of rail links and other public transportation here and in the rest of Europe. So whilst congestion, yes, is a problem in the UK, and for London and the Southeast in particular, we've actually found that a lack of direct rail links and public transportation networks can actually be a much bigger barrier to mobility than congested roadways. So as a result, we find ourselves having to look at two very different problems and solving those problems: congestion or connectivity. And in particular, we really need to understand what UAM is directly competing with in terms of ground transportation. As a result, we have begun studying these UK-specific challenges and how to develop the initial markets in order to meet those challenges. But first, before we go ahead, why don't we look at an example from the past? A lot of people know about New York Airways, but once upon a time, there was a London Airways too. Between 1978 and 1986, there was a Sikorsky Sea King, which used to do about 10 return trips per day between Gatwick and Heathrow. The really amazing thing for me was the fact that that had a huge number of passengers. It was about £75 per journey in today's money. So it was actually well used and well liked by the people who used it. And more importantly, it was profitable. But according to the Secretary of State for Transport at the time, it was a highly controversial issue. So why did it inevitably fail in the end? Well, there are all the main culprits that we normally see: noise complaints by residents under the flight path. And I mean, the Sea King is a very large aircraft. You can imagine that being quite an issue. There were also privacy issues for residents who felt that they were being spied on in their back gardens or in their swimming pools. But more important than the actual backlash itself from the public was the perception of backlash by politicians. And that was even more crucial. So once the M25 link was finished between Gatwick and Heathrow, only 4 months later, the Secretary of State actually revoked their permission to operate. Why? Well, what we can conclude from this is that it was only socially acceptable to operate this type of service with all of the downfalls of the noise and pollution, etc., as long as it was solving this problem of connectivity as opposed to congestion. I mean, the M25 is still very congested. It can still take a long time to travel around it, but it is seen as a reasonable alternative. So, where do we start? Well, looking at this idea of trying to find poorly connected areas as opposed to congested routes, areas where there are no reasonable alternatives to reduce the amount of time to travel on the ground, we can start to identify some of the most important use cases. But it is really crucial that we start to approach this in a lean way so that we can actually test the market and develop the right technologies without wasting a huge amount of time and money to get there. And as Gary mentioned, we want to be able to use these technologies at the end instead of finding ourselves in a position where we don't actually know what we're going to be doing. What we really need is an MVP, a minimum viable product, to understand the best use cases and capture real data in advance of being able to launch urban air mobility services in the future. The end goal for many of these technologies looks something like Uber's vision, which is high volumes of aircraft going in and out of very densely populated urban areas, using specifically designed infrastructure, vertiports, skyports, things like that, using automated air traffic control, potentially full integration between manned and unmanned. But let's face it, this vision is likely more than a decade away, maybe even two, and will require billions of pounds before it can be realized. So let's look at the minimum viable product that is required to develop and test and evaluate the framework for these services so that we can prepare the UAM environment for exploitation in the future. One of my favorite examples to talk about is the route between Oxford to Cambridge. Now, from some initial data sources, we have found that there are a fair number of people that need to travel or would like to travel between those two cities on a daily basis. And they're not very far away from each other, only about 100 kilometers. But because there's a lack of direct connectivity, there's no direct rail link, there's no direct motorways, it can take about 3 or 4 hours to travel that journey. Now, this is one of the more interesting use cases for us because those two cities both have airfields, which are operational and existing right now, which are about 10 to 15 minutes drive from the city centers. If we say that it's about 30 minutes flight time between them, what we're looking is that we're looking at a reduction of 3 or 4 hours down to about 1 hour journey time. Now, that's massive. Those types of connectivity solutions can be a really important mass market solution, looking at that public support issue, trying to understand how do we get a popular route. But there's an obvious barrier here. It's about, I mean, this is a quote that I received late last year. It's about £2,000 to do that flight between the two. The really interesting thing, though, talking about these new operating models, is how do we get that price down to a reasonable level? The first thing to note is that £2,000 actually doesn't represent the half-hour flight. £2,000 is the one single flight hour increment that charter companies will sell you. So actually, what we're saying is that £2,000 covers a half-hour trip there and typically a half-hour trip back with an empty aircraft, because the aircraft needs to return to its operating base. So looking at the H135, its maximum passenger capacity, if fitted out correctly, is about 7 passengers. And we think just by implementing ride sharing as a platform, we can reduce that to about £150 immediately. Further reductions, talking about new operating models, further reductions can be achieved by increasing the aircraft utility, eliminating brokerage fees. For me, one of the strangest things to understand is the fact that brokers still have a massive place in the charter industry and can form up to 50% of the cost of a single flight. And there's various other economies of scale that we can get when we start getting large numbers of flights and high utility of the aircraft. That can include reducing the cost of insurance, reducing the cost of maintenance, fuel, etc. So obviously, this is not a green solution, but this will help us going forwards and will help us to understand what are the first UAM routes going to look like. So looking at these first UAM routes, we think we can look at existing general aviation infrastructure without having to spend millions or billions on new vertiports. We can use existing light aircraft. We can integrate with existing services on the ground using shuttle buses or taxi services or ride-hailing companies. And we can reduce the cost if there is high enough demand and high utility for the aircraft. But of course, that is the challenge. It's only possible to do this if we can find these routes where there is a high enough demand. Therefore, we at the Avery Project have been developing a new methodology to identify these routes where we feel there could be strong use cases to test. We have been developing a highly data-driven approach that, at a high level, incorporates some of the cost and speed and proximity of rail travel and other public transportation services between city pairs like Oxford and Cambridge. We've been actually comparing that and contrasting that to the proximity of GA infrastructure, things like aerodromes and regional airports. To give you a really good example, I live in Stanmore in northwest London, and it takes me, any way you slice it, about 45 minutes to get to Paddington, which is my nearest rail hub in central London, but it actually only takes me about 10 or 15 minutes to get to my nearest airfield, which is Elstree Aerodrome. What that means is that there are going to be certain places in the southeast and potentially further out that are actually going to be a lot quicker for me to travel to an airfield and to be able to, even though the airfield on the other side is going to be a little further away from my end destination, could still result in massive time savings. The other element that we want to pair this up with, of course, is the social impact index, i.e. the positive, neutral, or negative impact of that service on a community. Part of that is going to be understanding what the noise profiles are going to be, but also it's about understanding the user data. So looking at how users feel about different services at different price points, and also looking at capturing some of that data to calculate the price elasticity of various different transportation options based on the trade-off between time and cost. Now, I just want to finish by talking about this element of social license a little bit more. As Gary mentioned, social acceptance and support is going to be a massive part of what we're trying to do. And everything that we're trying to achieve will all be for naught if we can't get the public on board. So, how do we go about creating a positive social impact? Well, talking about some of the things I've just mentioned, we can look at aiming to improve connectivity between areas with poor ground connections. We can be connecting remote communities that haven't really had that ability before. We want to, on the converse, avoid existing routes that are simply congested because they'll just be seen as options for the wealthy to sort of fly over the rest of us. We want to be reducing noise by avoiding populated areas. This means in the initial phases of rolling out UAM operations, we really want to be avoiding inner city flights and starting to look at use cases which operate for intercity flights. Additionally, we want to be avoiding the on-demand air taxis targeting wealthy elites or very, very small market sizes. Rather, we want to go in favor of scheduled low-cost routes for mass adoption, which will enable people to really get on board and say, well, if I'm able to access this, then I'm more likely to say I'd like the service to exist. So really, to conclude, I think that we've found there are a significant number of opportunities that are available for us to explore in the immediate, if not post-lockdown future. We don't need to wait for all of the other pieces of the puzzle, technologies and different aircraft to come together before we can start testing and evaluating aerial mobility solutions and use cases. So as a result, we are actively looking for consortium partners to collaborate on finding these use cases during phase 2 and hoping to speak with operators, vehicle developers, local authorities, airports, or anybody else who wants to build real use cases, not in 2030, but in 2021. Thank you very much.
Thank you, Nick. That was a really good talk. Thank you so much for putting together such an impressive presentation in such a short period of time. That's much appreciated. Right, we're now going to pass over to Brett Peterson from Vertical Aerospace. When you're ready.
Morning, everyone. I'm going to take you through a quick, there we go, that's the next slide. So first hurdle done. I'm going to take you through a relatively quick trip into the world of eVTOL aircraft design. But I'm going to try and show you this in a way of how that applies to potential use cases for these vehicles. So at Vertical Aerospace, I'm the aircraft architecture IPT lead, and my team and I are responsible for developing the overall aircraft architecture, integration, and verification. So to give you a bit of context and a roadmap for what I'm going to talk about today, we're going to take a quick view over some eVTOL aircraft configurations, the different types of those, and a little dive into what they mean for performance and potential use cases. We'll then zoom in a bit further into passenger eVTOL aircraft. And finally, I'll discuss what Vertical Aerospace are doing and have done in terms of developing full-scale eVTOL aircraft through design, manufacturing, and flight test. But first, I'd like to touch on electrification of aviation. And this is something that Gary mentioned earlier on in the day. And really, the electric and hybrid electric propulsion enables some broad new possibilities for aviation. And I've kind of put these into 4 different categories. And this, for us, as I'm talking today, really doesn't include smaller drones or infrastructure style drones, but really it's about private recreational vehicles, commercial intra-city, so within a city, slightly longer range between cities, or the use for public services. But actually the focus of what I will talk about is really about these 2. So it's the commercial intra-city and public services. And the reason for that will become a bit clearer as we start to talk about the potential performance of eVTOL aircraft. But before we get to electric vertical takeoff and landing aircraft, no discussion around VTOL aircraft would be complete without putting this picture up. For those that haven't seen it before, this is commonly referred to as the VTOL wheel of misfortune. And this shows a large number of different vertical takeoff and landing aircraft, these are all full-scale aircraft that have been designed, built, and tested. And you can maybe almost make out there that only 4 or 5 of these have actually made it into full-scale production. And these all have hydrocarbon power plants, so they have the power advantage that you get with that kind of powertrain. So this is really just to kind of show that there is a whole plethora of different ways that you can make conventional vertical takeoff and landing aircraft. But when you start to have the restrictions on the available power and energy of an electric or hybrid electric system, particularly when that's coupled with vertical takeoff and landing, that really kind of collapses down into 4 different categories. And for us, that is seen as electric helicopters. And this could actually just be existing helicopters that are retrofitted with an electric powertrain, but more likely it would be taking advantage of the electrification or hybrid electric powertrain for design of new helicopters. Onto multicopters, so anywhere from 2 rotors up to, I'm sure you've all seen some interesting concepts that have lots and lots and lots of small rotors, through to lift and cruise. And a lift and cruise concept is about having a separate powertrain for the lift phase of the flight compared to another separate powertrain for the cruise phase of the flight. And the last on the list is vectored thrust. And this is really about using the same powertrain, or potentially a slightly augmented powertrain, for all phases of flight. And actually what you need to do there is really change the direction of your thrust. And that can be through electrical means or mechanical actuators, or actually some kind of airflow deflection. But to dive a little more into each of these categories. So an electric helicopter, it has the advantages of being a known configuration. There's already more than enough complexity when you're putting an electric or hybrid electric powertrain into a vehicle. So actually keeping with a relatively known aerodynamic and structural configuration is quite beneficial. You have low power demands in hover. So this is really down to its large disk area, giving you a good hover performance. But the downside for an electric helicopter is really the number of safety critical components. And really this is about any failure of those safety critical components could lead to a catastrophic failure of the aircraft. And that makes it really difficult to actually hit the somewhat aggressive EASA safety targets that are out at the moment. You also have high power demands throughout the flight. And this is really because you're using your rotor to generate lift in the cruise portion of the flight, which for short, medium, and long range, anything probably above 5 or 10 miles, that's the majority of the flight segment. You can then move on to a multicopter. And really this gives you a higher level of safety if done well, because you can actually take advantage of distributed propulsion. And somewhat counterintuitive, this can actually give you a simplification of your architecture, because you can have similar or the same powertrain repeated throughout the aircraft. You have to be aware of common mode failures, but actually it lets you kind of introduce the safety benefit. But on the downside, again, you still have a high power demand throughout the cruise phase of the flight, and you lose the auto rotation capability of the helicopter. You might be starting to see already the pattern that there's no one configuration that is best in all cases. Moving on to a lift and cruise. So this is when you're starting to use a wing to generate your lift in the cruise phase of the flight. And that is a lot more efficient than using lift rotors or ducted air or any other kind of mechanism like that. So that really gives you much greater range and capability than the first 2 classes of vehicles. But you do end up with the weight and drag overhead because you have effectively 2 separate powertrains, one for the lift phase and one for the cruise phase. You also can have difficulties in managing the transition between the powertrain and the thrust generation of the vertical and the cruise system. And finally, vectored thrust. You can end up, if done well, with a lower drag and mass penalty because you're using the same powertrain for both your lift and cruise phase. But really, this does come at the cost of them being the most complex by far of any of the concept families. So really, your actuation system starts to become safety critical, and you can end up with some nasty coupling between your control system, your actuation, and the various vehicle failure modes. So that was a look through eVTOL families. I'd like to now give you a bit of a feel for how the relative performance of the different categories of aircraft perform. So unfortunately, I didn't get permission to bring the vertical crown jewels and be able to talk all about our aircraft concept design capability. But what I have been able to do is bring an example of some public domain data that gives you a good feel for how the different vehicles actually perform against a specific design mission. So this is information in the public domain from Mark Moore at the Uber Elevate Summit last year. So this is sizing eVTOL concepts around 1 onboard pilot and 4 passengers to complete a single 60-mile mission, and alternatively to complete a 25-mile mission, a short recharge time, and repeating that for 3 hours. But really a key assumption in any of the eVTOL design work is how good is your battery. You can end up with 30 or 40% of your gross takeoff weight of your aircraft being battery. So you can imagine that small changes in assumptions on your battery can have a big impact on if your vehicle is even feasible. So here, the assumptions that have gone into it is 180 watt-hours per kilogram. That's the specific energy. And that's at a pack level. So one of the things that you'll see in the plethora of eVTOL designs is people will assume the cell energy density and forget that you actually have to package this. You need lots of electrical components, lots of structural components. So you have to knock down your cell energy density to get to the pack level. You then also have battery degradation. So this is a specific energy at the end of life of the battery. So 180 watt-hours per kilogram is a fairly reasonable target. So what you end up seeing when you run this through some various different aircraft concept designs is you can end up kind of overlaying where the different families of aircraft fit for this specific mission. So to explain a little bit about what you're seeing here. So on the vertical axis, you have disk loading. And this is really the weight of the aircraft divided by the disk area, so the area of your rotor, or the area of the air that you are moving. And really, the higher that is, the higher power is required for hover or vertical flight. And on the horizontal axis, you've got a lift to drag ratio. And this is all about how efficient you are in cruise, in horizontal flight. So the best place to be on this chart is the bottom right. And you can see there that there's a line that says 4 kilopounds. So that is the gross takeoff weight of the aircraft to be able to perform this mission. So remember that this is a vehicle sized with around 1,000 pounds of payload, so 1 onboard pilot and 4 passengers. So if you could develop a vehicle down the bottom right of that chart, it would be roughly 4,000 pound gross takeoff weight. Now, as you start to go up, you can see that the highest number on those lines is a 12,000 pound vehicle. Now, actually, that means anything to the left of that, you can see where the multi-rotors and the helicopters are, means that actually at any size of vehicle, an electric multi-rotor and helicopter with these assumptions wouldn't be able to perform that mission. And that's really just down to the current state of technology of electric powertrains. So actually, as you go to the purple area there, slowed rotor compounds, that's where you start to have more advanced helicopter designs where you slow the rotor in cruise flight, so you reduce the drag. Lift in cruise, you can see, is heavier than a vectored thrust. It's above it on the chart. Now, again, vectored thrust can have lighter weight, but really it's at the cost of complexity. But I'd say the most interesting thing, apart from seeing where they lie in kind of feasible, infeasible space, is what happens when you change the battery assumptions. So this was all generated with 2018 battery technology. So if we skip forward to 2021 battery technology, you can see that actually that means that there are a lot more feasible vehicles just with 3 years change of battery development. Now, actually, that is expected to grow, but slowly. This isn't some magic assumption of battery change. This is actually based on cell test data that we have backed up with our own cell test data to kind of check that their input assumptions are reasonable. But you can see that actually there's still a whole category of vehicles that really can't perform the use cases as defined. So actually now to get into what we see are some use cases for passenger eVTOLs. Now really, I started broad and I've kind of zoomed in. So now we're in the realm of electric vertical takeoff and landing aircraft that carry passengers. Where do we see that the potential use cases are? And I've borrowed this, the background image here from the NASA Advanced Air Mobility campaign in the US. They're actually doing something similar to the Future of Flight Challenge. But really, this kind of helps to illustrate all of the potential markets that are starting to open up if we can solve problems like noise, privacy, as was mentioned by Nick before, and some of the economic issues. Now, actually, I'd just like to highlight the ones that we think are the nearest term feasible out to the longest term. So the color coding on here is green we see as the most near term, yellow following that, and orange being the most difficult ones to meet. So actually, we think that for passenger eVTOL aircraft, airport transfer, medical transfer, and cross-metro transfer is an interesting one. And that's really about going from somewhere outside of a city to the edge of a city where you have an efficient transfer to the existing public transportation network. Moving on in terms of complexity, you then have air ambulance and fleet operations being point-to-point scheduled. And finally, the holy grail of the urban air mobility market is the on-demand air taxi. So that was a look at eVTOL aircraft. I'd now like to talk you briefly through vertical aerospace and where we've gotten to so far on our journey. So we're using technology to revolutionize how people fly by making air travel personal, on-demand, and carbon-free. And we've been on a bit of a journey so far, and that started in 2016 when we were founded by Stephen Fitzpatrick, who was also the founder and chief executive of UK's largest private energy supplier, OVO Energy. And really the kind of ethos of starting vertical aerospace was about bringing together three key things. And it was the opportunities that have arisen through the electrification of aviation, renewable energy, and the pace of the F1 and automotive markets. And so the first challenge that was set is actually, can it be done? And this was started in 2016. So really it was, can you get a full-size electric vertical takeoff and landing aircraft? And this was the proof of concept aircraft, which was built by a team of 6 engineers. And it flew in September 2018, working closely with the CAA. And this is a fairly simple design, 4 ducted rotors and a full-scale prototype, which we did all of our test flight campaign at Kemble Airfield. So after we designed, built, tested, and learnt a lot from the proof of concept aircraft, we looked ahead to the next challenge, and that was really around how do we increase the level of safety and reliability of these vehicles? And one of the ways that you can do that with distributed propulsion is through increased level of redundancy. We also really saw the need to scale up to a useful payload. So this is our Seraph aircraft. And this is an aircraft which has a 250 kilo payload, speeds of up to 80 kilometers an hour. And this was also a really good opportunity for us to start to hone our company design tools and techniques. And we completed or did a quite substantial test campaign in North Wales. And I believe Jeremy is going to talk further about some of the flight test facilities we use later on. And this is a brief picture of us doing a flight test in North Wales and Lambetta. So I now have a short video which I wanted to play showing some of the flight test activities. So that is real footage. I know that it looks sunny in Wales, but I can guarantee that is real footage. So what's next for us? Now this flight test was, well, those images were taken last year. We are well underway with the design of our third vehicle. Again, this is scaling up, and this time this is a winged vehicle to try and get that kind of range and payload capability that I was talking about earlier. We passed our internal aircraft PDR for that back in January. So this is a maturing program. And this is really about us continuing the journey to develop and grow. We're now at a size of approximately 80 full-time engineers. And that includes our site in Oxford, where we're poaching lots of Formula One talent to help us accelerate this journey. So hopefully that's been a bit of context on eVTOL aircraft design, where Vertical are going, and looking forward to continue growing the consortium development for future of flight. Thank you.
That's great. Thank you, Brett. That was a really good presentation. Very, very interesting. So next up, we've got Jeremy Howard from Snowdonia Aerospace. When you're ready.
Good morning, all. Can you hear me okay?
Yes, we can hear you.
Good. Thank you very much. And thank you for the invitation to speak this morning. I think in the agenda, I'm down to talk about segregated airspace, but actually more broadly, I'd like to talk about possible use cases that could be developed from operations out of the Snowdonia Aerospace Centre. I know infrastructure was last week, but I do want to start off by talking a little bit about the infrastructure at the Snowdonia Aerospace Centre in terms of the context that then sets for Future Flight Challenge and possible use cases that will follow. And then in terms of those use cases, breaking those down, if we think in terms of drone use cases, the ability to carry a video camera and perform various search and surveillance missions, or to have some form of still camera scanning device that allows you to do mapping and surveying, or you can carry a package or a comms payload. And then moving on to electric aircraft and urban air mobility vehicles, looking at regional interconnectivity. And also one that's pertinent to us at Snowdonia, where we're also one of the candidate sites for a UK horizontal spaceport, is thinking about applications in high altitude and near space. And so what I'm going to do is, rather than go through all of these in any great detail, is just to give you a little snapshot of the type of activities that we've done to date, both ourselves and also with visiting teams. And to give you an idea of what the art of the possible is, and I'm sure you'll be able to join the dots and see how you might be able to use this environment for your own purposes. I'm also going to finish up just by mentioning the support of the Welsh Government that's also available for people operating out of Snowdonia Aerospace Centre. Okay. So a little bit about the centre itself. For those of you who are not familiar with it, this is a lovely aerial view of the Snowdonia Aerospace Centre, based out of Llanbedr Airfield in northwest Wales, up in the top right-hand corner of Cardigan Bay. Fabulous operating environment, very quiet part of the country, very remote, very rural, very low population density, very low air traffic density. And whilst that might seem not the objective of the Future Flight Challenge, it is a very good starting point in terms of having a safe and interesting environment within which to start generating new ideas. So another view, this time to the east, showing our position relative to the Snowdonia National Park. So again, operations in remote and rural locations, coastal, maritime, mountain, really a whole host of environments that make this a really attractive operating base. One of the things that people say to us is, oh, you're operating out of an old 1950s RAF airfield, and people have this mental image of what a 1950s RAF airfield looks like. Really, just to say the airfield has undergone significant refurbishment and upgrading over the last few years, and really is state of the art in terms of the facilities that can be offered to visiting teams. So a whole host of hangarage, offices, conference rooms, super fast broadband, really everything you need in order to move in as a team for a week, a month, a year, and conduct your flight test activities. Through the course of the Future Flight Challenge, we're also looking to implement an electric charging network, so we're better able to support electric air vehicles. And we're also looking to further enhance the air traffic management capability and bringing in elements of unmanned traffic management and other aspects that will make the whole airspace environment an attractive environment in which to operate. In terms of airspace, we do have an existing area of segregated airspace, a 10 nautical mile diameter danger area that's immediately adjacent to the centre, which then has a corridor that joins us to the D201, D202 danger area complex that sits out over Cardigan Bay. So arguably there's near enough 8,500 square kilometres of segregated airspace within which to start experimental activities. But one of the things that we're very keen on, and personally I'm very, very keen on, is that within the Future Flight Challenge, we look to explore beyond the danger area and look at the airspace integration issues into non-segregated airspace. And I've been talking with the CEA innovation team about how this little corner of North Wales could be viewed as a genuine regulatory sandbox. Okay, so moving on and to look at how this environment then could be used to support various use cases throughout the Future Flight Challenge. And as I say, these are snapshots of previous test activities that we've done both ourselves and with partners. First up, obviously, given the maritime environment, coastal environment, search and rescue is something that's very pertinent to this part of the world. Very popular with holidaymakers. The Birmingham Navy descend en masse in the summer months. And that combined with the Snowdonia National Park means that the Carnarvon search and rescue helicopter is one of the busiest, if not the busiest, in the country. There are also a number of Maritime and Coast Guard Agency stations and RNLI stations, mountain rescue stations within the vicinity of the test centre as well. And already we've done work in partnership with Bristow Helicopters and Kinetic, looking at how drones could be integrated into the search and rescue process. Another one, given the coastal environment, is work on maritime surveillance, maritime security, and the one particular task that I was involved in a few years ago was looking at support to fisheries protection. And this is an activity that is a devolved responsibility for the Welsh Government, as it is for the Scottish Government too, with relatively limited resources, a couple of old patrol craft, one on the north coast, one on the south coast, but they are looking to use a satellite-based situational awareness tool, picking up on iridium transponders that all of the fishing boats are supposed to carry, which obviously allows them to see where the fishing vessels are, but doesn't give them an idea of whether those vessels are actually doing anything illegal. So they're very interested in the use of drones to understand, do fishing vessels have nets in the water? Do they have lines in the water? Can we get an eye in the sky to give visual confirmation of whether that activity is legal or not? And that was quite an interesting proof of concept that we did a couple of years ago, and there's a lot more potential there. Another one that I was involved in, mapping and surveying, very interesting coastline, issues around coastal erosion, flood protection, flood prevention. We mapped the coast from Barmouth to Harlech down to centimetric accuracy, generated a 3D map, particularly looking at issues around the Artro Basin, which you see in the foreground on the left-hand side, which has known flood issues. That was a very interesting piece of work. And again, as an environment within which to explore mapping and surveying case studies, there's an awful lot to offer. Okay, next one up. And if you could start the video, please. So this is an activity that we completed people. As I say, I got kicked out. What you were watching, hopefully, was a piece of work we completed.
Can we just stop a minute? We're not. They're just making us live now.
Okay. With you folks, my apologies. I'm not quite sure what happened there. A few technical gremlins. I was kicked out for a minute or so. I don't know about you, and I'm not sure whether you have seen the video or not. But I think, in the interests of technical safety, we'll move to the next slide. Oh. Right. We'll just go with a still image. So this was a piece of work that completed just last month. In fact, immediately before lockdown, we had to cut things a little bit short. Working with the UK Space Agency to look at how satellite-enabled drones might be able to support remote healthcare networks in rural communities. And obviously North Wales is perfect for that. We were working with the Welsh Ambulance Service NHS Trust, and the particular use case that they were keen to understand was whether we could get defibrillators to people within the timescales required to actually be able to administer emergency care and obviously help save lives. So we did this little trial using a BVLOS drone and showed that we could get this little mini defibrillator to a remote location in a matter of 2 or 3 minutes, where it would have taken an ambulance 20 minutes plus to get there. So that was a very interesting use case. And actually package delivery in general into remote and rural locations is something that North Wales lends itself to very, very strongly. So that's a number of drone use cases. Moving on, looking at electric aircraft, regional and urban air mobility. We've obviously already heard from this morning from Vertical Aerospace. They're doing some really, really interesting work in this area. And as they mentioned, basing some of their flight test work out of the Snowdonia Aerospace Centre. And that's just a picture of their vehicle on the apron at the site. I want to talk a little bit about the little map, though, that I've inset on the right-hand side here. This shows population density of Wales. And as you can see, the population of Wales is spread very much around the coasts, nothing very much in the middle. And really, it's almost 2 countries, North and South Wales, that are separated by mountains. And although it's only 120 miles from that north coast to that south coast, it can take over 4 hours by road or rail to get from one community to the other. And in fact, it's often quicker and easier to go via England and come back into Wales again, which doesn't make any sense at all. So certainly, again, Wales lends itself very well as a case study for looking at regional air mobility. And I know that's something that the Welsh Government is very keen to support as well. And Chris Probert, colleague from the Welsh Government, will be giving a little pitch later on. As well as what we might think of as conventional aviation, we've also supported work by the Astagon High Altitude Long Endurance Team. That's an interesting case study, an interesting operating environment that we're able to support. From the airfield, obviously, out into the segregated airspace out over Cardigan Bay, that has an unlimited ceiling. So very high altitude testing out over Cardigan Bay is certainly a possibility. And linked to that, the activities that we're looking at, not just through Future Flight Challenge, but also our work with the Space Agency as a potential candidate horizontal spaceport, and looking at new and novel vehicles for being able to put payloads not only into orbit, but also into near space conditions where testing can be performed in a much more affordable fashion. And this little shot here actually shows the coast of Wales, although perhaps not how you would normally see it. It's looking north to south down the coast of Cardigan Bay, and was taken from a high altitude balloon by another one of our partners, B2 Space, from an altitude of about 90,000 feet. So hopefully what I've managed to do in just these very, very quick snapshots, and I apologize for the technical interruption, but just give a very strong flavor of the huge breadth of activities and use cases that could be supported out of the Snowdonia Aerospace Centre. I did just mention that I would touch very briefly on Welsh Government support. As I said, a colleague from Welsh Government, Chris Probert, will be picking up on this later in the little 2-minute pitches. But really just say that the Snowdonia Aerospace Centre sits within a level 1 enterprise zone within Wales, which means that it attracts the strongest level of Welsh Government support. and that there are opportunities for investment through the Welsh Government and funding through the Welsh Government to support R&D and innovation projects. And I'll let Chris pick up on that in more detail later this morning or this afternoon. Okay, so thank you all for your time. I'm more than happy to take any questions either now or during the Q&A session. Yeah, thank you once again.
Thank you very much, Jeremy, and I do apologise for the technical glitch there. I guess it's somewhat inevitable at the moment, but yes, I think your presentation was very clear with some very broad range of use cases there, so thank you very much. Okay, so we'll move on to Jack Withenshaw from Airspeeder. We'll have a break and then we'll have the Q&A session. So if you've got any questions for any of our speakers, please put them into the chat function, and we'll put that to the panel a bit later on. Okay, over to you, Jack. Thank you.
Thank you. Hi, everybody. My name is Jack Withenshaw. I'm the Chief Commercial Officer at Airspeeder. We're here to talk about UAM coming in at a very different angle and a very different speed. Airspeeder, in a nutshell, we're creating the F1 of flying cars, and I think we've heard today a number of call-outs for practical, short-term case studies or use cases, and I want to put forward the consideration of racing or motorsports for the next generation, as we call it, as one of those case studies. Next slide. Should we get to the next slide? Here we go. So I don't think I need to tell you all about the options of different UAM case studies that currently exist. We've got loads in the cargo space, loads in the taxi space, an industry that we're looking at totaling around the $1.5 trillion mark by 2035. I believe that's come down now by 5 years. And the amount of money and resources already gone into the eVTOL industry, $1 billion was invested just before COVID had struck. So really a space that's starting to heat up. And we can see that already with the volume of players that have entered the space. We've got the likes of Kitty Hawk or Bell or whoever in the taxi space, some in the recreation space, some announcements from the luxury side as well, Aston Martin and the likes of Porsche teaming up with Boeing. Now, when we started back in 2016, our founder, Matt Pearson, serial entrepreneur, he wanted to create a flying car company, and we looked at the world slightly differently. Now, maybe that's because we were founded out of Australia and we're at the bottom of the world, and yes, we do see things a bit upside down. But we looked ahead at what the flying car market or the taxi market would look like back in 2016, and we saw a bunch of challenges that still exist today. And those key challenges are around things like battery limitations, urban legislation, noise, certification, and awareness as well. So when we saw all these problems, we knew there were going to be huge technical barriers, hurdles that we had to overcome. And we thought, instead of figuring out when we could go and tackle those hurdles, we looked back. We looked backwards to see how mobility revolutions have been formed in the past. And we looked at things like Alcock and Brown crossing the Atlantic, competition that had driven innovation, civil aviation, which essentially helped create civil aviation pre-war. We also looked at things like the Schneider Trophy, a famous seaplane race that took place in the 20s and really accelerated engine innovation. And not just in aircraft as well. I think as we look at this industry, we're already seeing a fusion of both auto and aerospace really coming together. I think the announcement of Hyundai or investment from Toyota is just the tip of the iceberg here. So we look to things like the F1 and the innovations that have come out of that. So disc brakes, rear vision mirrors, handbrakes, seat belts. These are all innovations that have really formed part of the modern vehicle that have formed through the white heat of competition. So we saw that there's historically a precedent for racing as a use case before any mobility revolution can really take place. So we thought, right, what if you applied the same lens, racing lens, to the UAM industry? And what we saw was that it became a lot more feasible. You could race in remote locations. So you're not flying over cities or over dense populated areas. You could fly with qualified pilots to be able to minimize the risk exposed to the pilots that you're having in these vehicles. You are able to have battery swaps, or essentially electric pit stops. So if you're flying in circles, battery length is not so much of an issue either. Noise. Well, in motorsports, noise is welcome. In fact, we love it. So if there are any engineers out there that are really concerned about sort of reducing the noise levels and want to go the other way and want to make them louder, please do come start knocking on our doors. So we looked at the framework of what racing could allow, and it meant that it was a much easier path to creating a market and getting this industry going. And on top of that, it also meant that those restrictions that do apply, I guess, to the UAM industry that don't apply it to racing means that we have a test bed that can really get going before the UAM market comes. And instead of focusing on those problems, such as noise, batteries, legislation, certification, whatnot, we have our own ones that we would be concentrating on. And this is true for all racing. There's three areas, which is safety, performance, and awareness. So these are the three kind of core areas that Airspeeder will be trying to focus on. Now, safety is, of course, the biggest paramount when it comes to motorsport. We want to be able to crash well and take those learnings so that our pilots can survive and hopefully get to some sort of fisticuffs in the middle of a race. But it's about taking those learnings and then applying them back into the UAM industry to be able to take that data in an environment where it's understandable that you are going to crash, but to be able to freely share those learnings with the rest of the industry. And we're doing that through creating a lot of learnings from the motorsport industry, building monocoques into our vehicles, and really recording that data and feeding that back. On the performance side, what we're doing is we're not trying to reach a price point what you have to do if you're trying to look from a mobility standpoint. We're building using tier 1 F1 manufacturers and technicians to be able to come in, create a high-cost vehicle, essentially hand-built, low volume. And what that means is that you end up with a very high-spec vehicle, something at a performance standard. And because of that, there's a ton of learnings that we can inject back into the industry, as opposed to trying to focus on mainly getting that breadth of distance and safety there. What we're actually focusing on are things like agility and performance. And really at an extreme level. When you're racing, you have extreme drivers, you have extreme conditions, and through that is a ton of data that we can kind of feed back into the industry. Now, the big one I think is awareness. This is my view, but I think the industry has a taxonomy problem. eVTOL is a very unsexy word. It's hard for a lot of the public to be able to understand where this technology is at, where this future that we've got for flying cars is actually not that far away. And I think we're in a little bit of a bubble here in this world. If you speak to anyone outside of that bubble, they're really astounded. Now, sport offers a really packageable and palatable way to be able to translate the level of technology that we've achieved in this industry and get some really nice wide cut through across all demographics. So we see racing or Airspeeder as a vehicle to be able to help educate the public in not only the capabilities of these vehicles, but also putting a human face to them as well. I think it's all well and good having the idea of an autonomous vehicle flying around, taking you from A to B, but I can't see anyone in my family jumping into one of those without any sort of education. What we can do through this race series is take them on that journey so they can see the level of progression that racing iteration provides, i.e. every single year getting better, faster, quicker. Have a human face that they can trust and understand and to help educate them, and that'll be from the pilots or from the engineers of the teams that they'll be following. And to be able to really kind of take the public on a journey to be able to help break down the awareness barriers, but also the public acceptance barriers that come with it. Now, our philosophy is we're very open in terms of sharing a lot of this technical knowledge as well. We want to be able to provide it all back to the UAM industry to only turbocharge it. It's one of our 3 values, which I'll touch on in a second. And it also extends to a STEM program that we're launching next year. We're working with a leading standards manufacturer to really start to grow the base of talent in this industry, and doing that to attract talent into it through sporting competition. So to create essentially an Airspeeder junior series that'll help be able to feed talent, not just for ourselves, but for the other eVTOL manufacturers and the wider the wider UAM community as well. So we look at a case study here that is driving safety, driving performance, helping the public understand and acknowledge and accept that this technology has got to this level. Meanwhile, able to generate significant revenue. We've got our first sponsors on already with DHL and Equals as our primary sponsors for 2019, and very excited to reveal who our sponsors will be for 2020 as well. And most importantly, it's historically proven. This is what's happened in the past with aviation and motorsports in conjunction with the F1. So it makes practical sense for this to be the first step into launching the eVTOL mobility revolution. So I'm going to move on to a video in a second to give you a bit of a hint as to what we've been up to. And hopefully it will play and not throw everybody out of the There we go. Well, hopefully you got the audio. If you did, you can understand why I see that video every single morning. Better than coffee, gets me excited. It really pumps us up. And what you saw there was just a snapshot of that historical legacy that we're trying to employ for the future and build upon. Now, who are we? What do we do? Well, we build manned electric multicopter racing series. That is an absolute mouthful. I think a better way of explaining that is showing a bit of an image like this or something like this. Now, the vehicles that you see in front of you, we call that our Mark IV Speeder. It is essentially a lipo-powered octocopter that has a monocoque, single pilot, and will be the vehicle that we'll be racing for our 2021 series. We've been building up our prototypes for the last 4 years in Australia, and have just opened a technical facility down in Adelaide. That is where we've been building our prototypes, which will be flying, well, we're due to fly this year, and set some new records as well. In doing so, really kind of showing the world that our technology is to a stand where we can start racing for the next few years as well. Now, to give a bit of insight as to how we think and what we're trying to achieve, we see this as a sport first and foremost, with purpose inbuilt into it. So a sport that's designed to inspire a new generation, if that is a new generation of fans or a new generation of adopters of these vehicles. As innovative, as I said before, we want to use competition as the biggest driver for innovation, and then feed that innovation back out into the market, so that this industry can take off. And as sustainable as well, I think a factor for any modern sport is it needs to think about the environment and how that's positioned as well. A little bit about the race series. While initially we'll be doing head-to-head racing, we will eventually be looking to create a full-scale motorsport whereby multiple vehicles will be able to be on the track. We've developed a collision avoidance and detect and avoid technology to be able to have these vehicles not physically interact. Safety is paramount, not only for our pilots, for our investors and brands that are involved with us, but for the industry as well. So that's something we've been working out throughout the series quite significantly. There'll be electric pit stops, multiple teams, and most importantly, it's going to be biblically loud to be able to create excitement around the sport as well. And look, we're not restricted to flying over modern racetracks. We can fly over sand, canyons, water. We've got a number of showcases that we're planning before this pandemic for this year. There were showcases in the Middle East and showcases in Asia. But our racetracks are to be announced for the 2021 season. And they're going to be a combination of beautiful environments as well as historical race courses or racetracks that we've seen in motorsports history. Some locations is, first one will be in Kupiti in Australia, in the deserts there. Second will be in the Mojave Desert. We're planning to do that in August this year, but that's now been pushed back a little bit. But race locations in the Middle East, across Asia, as I said, traditional race tracks that we are familiar with, and some new ones as well. This really, as I said, it's a sport, so it's really about audience and who's going to watch this. And I challenge to say, who wouldn't want to watch something like flying car racing? It's going to tap into motorsport audiences, drone racing fans, esport fans, and a whole new fresh plethora of fans as well. And the way we broadcast this is going to be through own channels. We're going to be using third parties that we're in conversations with to be able to release the series. I cannot stress enough that we won't be doing live races for the first few years for obvious reasons. Really controlling the sport and releasing it gradually is critical for the ecosystem around us. As I said, it's taken us 4 years to get to this point, but we're really excited about what's coming up next. And these demonstrations across Middle East, Asia, Australia, and the US are really just the beginning. Now, in terms of what we're doing in the UK, we are primarily based out of Australia. That's where our manufacturing and engineering is all centered. However, all commercials, marketing is done out of London. While technical center is in Australia at the moment, there are long-term plans for Airspeeder to be able to bring this out to the UK. Personally, I think the UK motorsport scene could do with a little bit of a boost. And I think while that makes a good choice for us, it's really kind of like the guys at Vertical. There's a ton of F1 talent that we can draw upon to be able to accelerate the series. So the vision here is to really build a new British motorsport from 2022 onwards. In terms of what we're looking for, any partners that want to be able to use this as a critical test bed, or a sandbox, would love to be able to talk about how we could help progressive technologies through competition and sport. Thank you.
That's great. Thank you very much, Jack. And again, thank you very much for stepping in at such short notice and equally impressive slides. Okay, so that's the end of the main speaker session, and I guess at this point we do a virtual clap to thank all our speakers for their presentations today. Thank you very much. We're now going to move on to a bit of a break, and when we come back at 11:50 will be the Q&A session, and then we'll have the pitch presentations. If you've got questions, please put them in the chat box and put those to the speakers in the next session. So thank you very much, and we'll see you at 11:50. Right, so we're now going to move on to the Q&A session, and we've got some questions that have come through on the chat box. So the first one is for Gary. Is the physical demonstration 100% necessary, as it seems like a bit of a needless distraction if the real innovation is potentially to be found in the virtual simulated space?
Hopefully I'm unmuted. There were lots of unmute messages popping up there. No, I don't think it's a distraction. I think both are necessary. There always are, in aerospace and aviation things, there is always a point proving that the system you've simulated is right. We cannot prove our simulations are 100% right. So we've always seen it, and I maintain there's a hybrid of such things. What I think we need to not do, though, is become over obsessed by the physical demonstration, because that's the stuff that gets the headlines, is very visible, and we should always be striving for those things which can be demonstrated adequately by a system simulation. So no, I don't think it's a distraction. It will be necessary, but we have to get the balance right.
Okay, thank you. So for Nick, how would your scheme compete with the rail network that is being developed between Oxford and Cambridge, East West Rail? Expected journey time, 1 hour and 15.
Sure. So we're aware of the that new railway that's being developed, or rather redeveloped, and I don't think that UAM can actually compete with a railway system like that. But I think it's really telling, the fact that this issue of connectivity for those two cities and the regions in between is so bad. There is such little connectivity that the government has chosen to spend millions, if not billions, in building this new railway. Now, the real question is, if we refer to things like HS2 and other major infrastructure projects, it kind of it's inspiring to think, well, do we have to go through that multi-decade construction process, or could we substitute certain parts of it with UAM? I mean, there will always be branches of different areas of the country that are not able to be served by major rail networks like the new Oxford-Cambridge Railway. But I think it's just interesting to think about what can you do that adds to the overall transportation system without having to create that massive infrastructure project.
Okay, thank you. So Brett, great talk. Would you explain why a multicopter cannot auto-gyrate if it loses one of the powertrains?
Sure, that's a good technical question for me to give a brief answer to. So really, that's around the size of the rotors. So a helicopter has a large rotor which stores a lot of kinetic energy, which can be used to create a somewhat soft landing in the loss of a powertrain. For a multi-rotor, you have distributed electric propulsion, so you have smaller rotors, which also tend to be fixed pitch, so they don't actually store enough kinetic energy to be able to soften the landing. So that's why you actually see so many rotors sometimes on multi-rotors, because they have to provide safety through assuming one of them will fail, and the rest of the system has to be able to continue to function and provide enough lift. So it can't auto-gyrate, but there are other safety benefits of a multicopter.
Okay, thank you. So the next question, they haven't put who it's targeted at. We think it's Jeremy, but pitch in anybody. What the circular error of probability was for the drops?
Probably is me. Oh, tight.
Yeah.
Can you hear me okay?
Thank you. Yeah.
Yep. So for the drops that we did, we deliberately offset the target point by 50 meters to start with, just as a safety precaution. And unfortunately, due to the lockdown, we didn't really get enough chance to do further flights that would refine that. But given the ones that we did do, and we did a few practices over the airfield as well, our view is that we could get the CEP down to about 10 meters.
Okay, thank you. So this one is for Jack. Where do Airspeeder get their $1.5 billion market evaluation from, please? And is it agreed?
So that figure was 1.5 trillion, and that was actually a predicted figure for 2040 by Morgan Stanley in their January 2019 paper. At the Vertical Flight Society, there was talk about that being brought down to about 2035 due to the recent investment. The other figure I quoted was the $1 billion investment that had happened in the pre-COVID pandemic. That has largely been contributed by the likes of a $600 million Joby raise, 280 from Lilium, and the rest from other partners in the industry.
Okay. So while we're with you, how will Airspeeder compare with Air Race E on speed and public acceptance?
Yeah, so we love what the guys at Air Race E are doing. Jeff and the team there are doing some amazing things to be able to accelerate electric aviation in a very similar way to what we're trying to do for the eVTOL industry. I look at their product as an air race, and I see ours sitting more traditionally in the motorsport section. We're trying to port across motorsport fans and audiences to be able to raise acceptance for the eVTOL industry as opposed to electric aircraft. In terms of layouts and speed, just due to the nature and the style of the craft that we've been creating, we will have probably more agility and performance-based turns in the races, whereas from what I've seen already from Jeff's team, that's going to be more of a traditional air race format.
Okay, so I think the next one's for you as well. Is creating a use case where the vehicles regularly crash a good idea for public acceptance?
Yeah, this is an interesting one. I think we all agree that we've got a very common philosophy around the aerospace industry, which is don't crash, do not crash, never crash. It's something that's going to happen, and it's going to happen a lot. What we want to endeavor is to be experts in it. Now, as a showpiece, I mentioned we won't ever be showing this live, or at least not for the first few years. So it's going to be really contained as a product for the public to be able to engage with. So what we are going to be showing is the fantastic elements of the sport, the speed, the performance, the names, the pilots, and get them excited that way. Crashing, which is inevitable, will happen in a lot of the races, and for that, that's about learning. I think it's also it's important to understand that this is the reality of what this industry could potentially do, but becoming experts in it, accepting it, and kind of minimizing the risks that come out of it through the framework of sport is a much safer way of approaching it.
Okay, thank you very much. I'm just so this one is for everybody. In trains, regenerative braking has been used to save energy for electric cars as well. Is anything like that being considered for electric flight during descent? Does anybody want to address that? Or...
I'll jump in and have a go. So I guess what you actually get with an electric powertrain is that you have kind of deep throttling capability effectively. So actually during your descent, you're able to reduce your power usage down as much as you want. So actually having the electric powertrain or a hybrid electric powertrain gives you the ability to tailor the power usage to your flight profile. So to the specific question of kind of regenerative braking, I haven't seen that be used in any of the concepts that have publicly available information. But actually you kind of get benefits just through the electric or hybrid electric powertrain anyway, in that kind of descent phase of flight. You could also look at something like an e-taxi scenario for a conventional electric aircraft, and that starts to become quite attractive because you've already got the electric infrastructure on the aircraft. So actually e-taxi starts to become very, very useful to integrate in that area.
Okay, thank you. So again, I think this one's aimed at anybody. Not many people are looking at e-planes to replace high-speed trains. Why is this? A quick calculation shows that for micro haul, less than 250 miles, e-plane capital and running costs are lower.
I think I'll jump in with that one. One of the really interesting things is that trains inevitably have a huge amount of capacity in comparison to electric aircraft. Even though you are potentially going to have per capita lower costs, you won't be able to match the same level of volume for quite a while without creating probably very large airports to be able to deal with it. So it's at the moment, we in the UAM industry sort of think of this as much smaller scale passenger capacity, which at some point may evolve into electric aircraft replacing some of those journeys. But it's really down to how the scale of development progresses over the next couple of years.
Can I dive in and add to that as well, please? So a couple of things spring to mind. One, in terms of why they're not, I'm not sure I know the answer to that fully, but I would say one of the things that surprised me most coming into this world a year ago, and it's one of those things that seems really obvious after the event, when you look at the potential economics of electric aircraft, it is a game changer. So you get with all of the technical challenge that all the people on the call and others are working on, it's not trivial. But when you get to the point where you can do sensible missions with electric power, the essential cost of energy is far lower. Then if you come one that's little sensitive, but you imagine a world in which you can do that stuff autonomously, pilot free, if you look at the basic economics of operating aircraft, that's a really big slope. So there actually are some missions that become significantly much cheaper, and particularly some of those short haul missions. I would still suggest that in the wider world, I'm not sure that's really understood. I think people think that we are looking at this for radical and exciting new markets, and we are. We're looking at it as a device to initiate and support decarbonisation as a social good, which we are, but the basic concept, the operating economic, could be completely different. I'm not sure that's widely understood, so people will wake up to that. The second point I was going to make is that we should never see any of these things, and I don't think the question is intending that as binary, either or, which is the right solution, because the reality is we'll see much more integrated systems and multimodal transport. Daryl Swanson, who gave one of the talks last week at our infrastructure networking event, Daryl did a really good illustrative job looking at London about how people may fly into a place, but then it will be what other places can connect to that flight landing pad, if you like, via electric train, via electric scooter. So I think there's a whole network of change coming in infrastructure for transport, and I think they will all have their place to play. And one of our jobs is to make sure that aviation is seen to be a component of that, make the options available to people, but it will be all avenues of development will be important to get us to the mobility we want in the future.
Okay, thank you. So for Gary, while we've got you there, can you just clarify the point around people who are not successful in phase one and reassure them that they can apply into phase 2 and 3?
Yeah, there are a few messages we've realised we just need to keep giving for whatever reason. So Future Flight was crafted right from the get-go. It was crafted to allow people to come on board at any point throughout it. And that was because we said we knew we wouldn't have the full understanding of what was required at day one. So the whole architecture of the competitions is anybody can come in at any point. Of course, anyone can leave at any point as well. So yeah, we're completely receptive to that. The phase one winners had we think a positive win from winning that competition, as they got to engage with each other for 2 days. They got to help us directly in shaping the competition. But now when we start phase two, we reset, because submissions come in from anyone and we'll judge them on their merits. You don't have to have been in earlier phases to be in this phase. You don't have to win in phase two to take part in phase three. We're very open.
Okay, thank you. I'm not going to get through all these questions, so we'll just have to follow up with you on that. So for Jack, how will you enable or control the radical innovation that will come an issue in Formula One, as people are well aware?
Yeah, I guess the innovation is really through the theory that nothing drives innovation faster than competition. Sport war. For us, we want to go to market as quickly as possible. That means we're going to be emulating a Formula E style approach, where we have a single manufacturer for all teams for the first few years. And that'll be a turnkey solution for our racing teams. And we're doing that to allow traditional auto players to be able to come into this space a lot more easily than they probably would have if they went directly into the eVTOL industry. We will then be having a single design, single manufacturer for the first series or second series as well, and slowly loosening the reins on what can be applied. As those reins loosen, innovation will be able to be created by those teams. If it creates the vehicle to become faster, stronger, or safer, by consensus, we'll then be able to bring those technologies into the series and to the public domain.
Okey-dokey. And just quickly, a couple of minutes. I'm not sure who this is aimed at, but given conventional helicopters safety issues, it is for Brett. So I'll try that again. Given conventional helicopters safety issues, does Vertical Aerospace want to discuss this as an early opportunity?
So that's an interesting point. So we've been doing some of our own public engagement with the static display of our Seraph aircraft in Canary Wharf a few months ago. And this happened to be 3 days after the recent Kobe Bryant helicopter crash, which wasn't great timing. But actually, that was a good opportunity to show how careful we have to be with messaging about the type of aircraft that we're trying to develop. So the safety targets and the safety requirements for eVTOL aircraft, as defined by EASA, are the same as large commercial aircraft. They are literally 100 or 1,000 times higher safety requirements than conventional helicopters. And that's a really important message for us to get across. So actually, as kind of an industry or a network that we're trying to pull together in consortiums, I think it's really important that we work on the public messaging about what we're trying to do as much as anything, because there are really fundamental differences with the type of aircraft that are being developed now compared to a conventional helicopter. So I think this is a broad topic that we all need to kind of accept some level of ownership for, not just the vehicle developers.
And again, if I could just come in and add to that, I think that's a really good answer. What we said as a future flight challenge is that we want to support the creation of this new aviation system with these radical new vehicles. But at the end of it, that needs to be at least as safe. And as a kind of 29 years aerospace engineer, our mission is always to make things safer. So at least as safe as the best of the current aviation system. So the total system, dead right, we're looking to be, that will look like large passenger transport at least, which is really important. And it will be partly around the vehicle, but partly about the entire end-to-end system, from the maintenance regime, the flight traffic management regime, what degree of redundancy do you need in the system, what degree of separation and distance. We've just started a piece of work, a very early stage piece of work, looking at that total enterprise safety case and what needs to be done. So the thing you said there, that everyone needs to play their part, is completely right. Absolutely, this needs to be much more safe than the helicopter market itself.
Okay, great. So we're going to move on to the pitch presentation section now. If you do have any more questions, feel free to put them in the chat box and we can send them out to the speakers and get a response for you. Or we can connect you to any of the speakers that you hear today, so that's no problem at all. So with the pitch presentations, they are 2 minutes. I will be timing on my phone. Obviously, the difficulty is that we don't have visual cues, so I will put my timer on. When the timer goes off, you need to stop. Natasha will put you on mute and we will move on to the next speaker. So first up will be Richard Vilton, who's from EMU Analytics Limited. So you'll be unmuted and then you can begin your presentation and I will time as soon as you talk.
Good afternoon. My name's Richard Vilton. I'm the CEO and co-founder of EMU Analytics, and apologies to anybody who heard me pitch last week. It's much the same. EMU Analytics is a London-based SME, and our technology solution is a data analytics and visualization platform that is designed specifically for big, fast, and real-time geospatial data. So typically the sort of data that would come from large-scale IoT sensor deployments, big networks, transport systems, and underpinning a lot of smart cities initiatives. We work with multiple large enterprises across several different sectors, including infrastructure, transport, energy, and most recently, aviation. Could we go to the next slide, please? So we already work with the likes of Heathrow Airport and with International Airlines Group, bringing to life data that's derived from everything from ground vehicles to aircraft and flight paths. And really what's unique about our software is its ability to not only ingest and process these very large volumes of data, but to turn them into insights that are then very accessible and very visual, very easy and intuitive for your audience of that insight to then interact with. With regards to this future flight competition, what we are keen to do is to put ourselves out there as a potential partner or subcontractor to any consortium that is looking to either generate or procure large volumes of geospatial data that they want to present as part of the output of that project to whoever the audience might be. So my contact details are all on the slide. Please feel free to reach out to me if you have any thoughts or considerations as to how we might be able to work with you. Thank you.
That's great, thank you. Well within time. So next up, David Stanningford from Xenotech.
Oh, hello everybody. Yes, David Stanningford from Xenotech. I'm one of the directors and co-founders here. We're a high-tech micro SME based in the southwest in Wales, and our technology base is all around high-performance computing and computational fluid dynamics. The background of all of the team is in aerospace, but we've now broadened into automotive, civil, and latterly renewable energy sectors as well. The key focus for the company is on delivering simulation capability that's highly scalable and cost-effective, that's led us to provide cloud computing capability as a back-end for most of our on-demand services. We've got quite a long pedigree in designing aircraft with CFD, a little example at the top right-hand corner there, and working with certification bodies in the US to bring those products to market. If we could just do the next slide, please. But the urban airspace, of course, is really quite different to the traditional flight envelope of a standard aircraft. And in particular, we're interested in the features around an urban environment, as you can see on the left there, vortices, channeling effects, highly unsteady and turbulent flow. And in fact, we've already been engaged by DSTL under the DASA program, project called AirSight, to deliver a military system for automated aerodynamic hazard avoidance for urban UAS operations. And that program is live at the moment, and it leverages our existing technology stack. Basically, what it does is it feeds data about undesirable aerodynamic characteristics directly into the platforms at the moment through their hazard avoidance systems. So within future flight, obviously what we'd like to do is partner up with other supply chain actors. I have a feeling EMU might be one of them, to deliver that capability in the civil space. And you can see the list of people we'd like to work with on the right there. So hopefully you'll get in contact. Thank you.
Thank you. Okay, next up is Paul Riley from City University of London.
Good afternoon, everybody. Yes, Paul Riley, City University of London. We completed a feasibility study into a disruptive form of power electronics middle of last year. That was applicable to automotive. Since then, we've been working with a large French and a small German company looking at aerospace applications. Next slide, please. The idea is that you use fairly low voltage MOSFET transistors, but then you can generate very high voltages if you wish to drive either fans or propellers. The main application or the main interest in aerospace is that it's 20 times lighter. The power electronics are 20 times lighter compared to any other power electronics. It's also easier to get rid of the heat. You don't need big radiators to get rid of heat. It's inherently safe. No high voltages are present if the fan's not turning. It's scalable from fairly low numbers up to very high tens of megawatts. And it also includes a two-way system, so it can ultra fast charge the batteries. The other advantage for fan-based higher altitude electric planes is that we can give a higher takeoff performance without having some of the corona discharge problems you get at altitude with conventional battery systems. What we're looking for is engineering firms that are interested in the larger E-planes to take it to the next stage, mainly for UK. We're already talking to large people in Europe, but we're looking for UK people that will help us exploit this and take it into other systems. Certainly, one of the presentations this morning about racing flights, they may be interested in the advantages that this technology can give them. Thank you very much.
Thank you very much. Okay, next up is Neil Stone from Leapstone Limited.
Brilliant. Thanks, Michelle, and good afternoon, everyone. I'm Neil. I'm the former head of design at British Airways, where many moons ago I led the design of flatbeds in business class in 2000. Today we've heard lots about brilliant flight technology, but I'd like to talk briefly about human-centered design and need. Leapstone's a specialist SME. We work with associates and other design specialists to deliver work. We help clients use human-centered design to scrutinize and solve problems. And the sorts of outputs we might see from our work is improved products, experiences, processes, or systems. We work across the commercial, public, and third sectors. So, for example, we've worked with Intercontinental Hotels Group on guest experience and innovation, worked with the NHS on reducing violence and aggression in A&E, and various charities on supporter engagement. And on the second slide, please. Our ethos is that real innovation actually demands that you fully explore the problem before you embark on ideating, or else you run the risk of coming up with really cool technology or ideas that have no use. We're independent, which means we can help you focus on the right challenge and therefore get to better solutions faster. And because we're neutral on the nature of the output, it means that the scope of output is very broad. By contrast, a product design firm will give you a product type answer. We offer loads of different services with our clients, but design strategy and management might be important here. Integrating a wide range of stakeholder views, for example, those of the public, into your project, setting up human-centered research and learning from it, figuring out what the best design response might be. And we'd love to help teams that might need their technical concepts challenging and shaping through real-world human-centered use cases. For example, what does the baggage allowance or end-to-end experience look like for city edge payload constrained eVTOL services? Thanks very much.
Great, okay, just in time. So next up is Will Searle from Exilium. He's there, Will? Is Will there? No? Okay. Okay, well, maybe we can move on to the next one then. Alex Freyas Airfield from Airborne Robotics Limited. When you're ready.
Hello, can you hear me?
Yes, we can hear you.
Okay, great. Yeah, my name is Alex Freyas-Airfield. I'm the CEO of Airborne Robotics. We are an SME based in London, a manufacturer of drones with track record and advanced product. We have strong development capabilities and also integration, customization capabilities. We have compelling performance specs, which is in particular interesting when it comes to development projects. Our drones can fly up to 60 minutes and have payload capacity up to 10 kilos. Next slide, please. This is a image of our flagship drone, the Air 8 drone. It's compact, so it fits into a box of 70 by 70 centimeters, but it's at the same time very powerful. As mentioned, it can take on a payload of up to 10 kilos or even more. As a company, we are innovative and forward thinking. We think in autonomy, full redundancy, in particular urban area and BVLOS scenarios. We think in centimeter accuracy and also GPS denied areas and also autonomous charging. When it comes to applications, here are a few listed: power, rail, infrastructure. So that's all about corridor surveys and digitization, monitoring, but also logistics. We've seen medical drop-off scenarios before, and also first responders. Those are our applications. We like to collaborate, so if you're interested, get in touch. We support any ideas with aerial autonomy. Thanks a lot.
That's great, thank you very much. We're just going to hop back to Will. Will has found the unmute button, so we'll just let you make a start, Will, please.
Too many screens, Michelle. Thank you. You can hear me, I hope?
Yep.
Perfect. Thank you again. A similar message to a previous speaker. We've presented this in the past. Just an update from today, though. We've moved forward. The key slide you'll see on the screen is about a use case for connecting 5G to test beds, which is quite a now mature use case. So we're starting to move forward to the wider intent of what the Alliance delivers. So we're working very closely with Cranfield University. Axelima is based in the East Midlands, and we are moving towards a co-location at Cranfield. The focus, though, of today's pitch is if you are looking for support in the wider aspect of building the value chain, i.e. new emerging small businesses, large businesses with a need to understand the challenge, please get in touch. It is about 5G at the moment, but the strategy for the Alliance is a longer term support to the value chain. And if you jump me forward one slide, Michelle, for those that are interested in the 5G, and we are fundamentally putting a 5G base station onto the ground, one into the air, and we're using secure public-private 5G slicing to join the dots. It's a complicated scenario, but if you'd like to get in touch, please do. But again, to reiterate the previous message, the Alliance is about supporting the value chain. Very keen to hear from all parties who want to look beyond 5G and support the long-term scale-up of this sector. Thank you very much.
Thank you, Will. Okay, next up is Andrew Chadwick from the Connected Places Catapult.
Hello, everyone. So I'm from the Connected Places Catapult. Thanks, Michelle. So we work across government and industry. We note we're the DF, Department for Transport's Innovation and Technology Partner. And on our unmanned aviation initiatives, we work on the Government Drone Pathfinder Programme, the National Open Access UTM framework, and we're a member of the Drone Industry Action Group. We have expertise in transport modelling and decision making, which also is supported by the business analysis, and also we have unmanned aviation experience, including UTM and BB loss operations, market sector knowledge, including use cases, transport infrastructure, and also in human factors. Next slide, please. So our project idea is the development of a seamless, sustainable, connected transport system which has aviation at its core. So this is a unique way of looking at how we connect transport within this country. The services that we offer are in two main areas, one on the UTM side of things, so the open access framework, which we're developing with a number of UTM companies, and also with the CAA and an ANSP. So we have that as a baseline for UTM trials, and so we can demonstrate the design, the architecture, and also the protocols for operating UTM systems in the UK. The other one, which is the topic of today's webinar, is on the BB Loss program. So as the Drone Pathfinder program, we have a number of use cases and also lessons identified from that program. So use cases covering everything from long linear operations in rural remote locations, so for the electricity infrastructure market, for example, and also large area operations. So for example, one of the Pathfinders we've just recently kicked off with the Maritime and Coast Guard Agency. So there's a lot of lessons identified there. We have knowledge of the market requirements, the specific use cases, how it works, the market analysis, and so we're providing that support and services into this program. And then finally, on the future and mobility side of things, again, it's around the future, it's the market and demand modeling and how we integrate everything with the transport modes and the infrastructure. That's both physically, digitally, and also the energy side of things. We're also widely experienced in public engagement and developing business cases. So we're looking for partners, companies with mature UTM capabilities, mature US service organizations, and also local authorities. Thank you very much indeed.
Thank you for that. Next up is Stephen Eisen from De Montfort University.
Thank you for providing us with an opportunity to say a little about ourselves. Stephen Eisen and Lucy Budd, two professors at Leicester Castle Business School, DMU, within Leicester, as you said. Our focus over many years has been on air transport policy and air transport management with elements of public acceptance. So if you partnered with us, you would be collaborating with academics with a long-standing record of research in aviation, both with industry and government, and our contact details are there and our website, so you can see details about us if you want to. Second slide, please. Project ideas. Well, research into users and public perceptions and acceptance of future air transport innovations, such as UAM, UAVs, and also at the rural level, an interface between manned and unmanned aircraft, integration into existing ATM protocols and airspace architecture. What's innovative? Well, lots been talked about the technology. It's very important, of course, but we need to understand also the human element, how people perceive future flight initiatives, barriers to implementation, public acceptance, whether that's in terms of price and price elasticity, noise, sustainability, airspace management, and so on. What can we offer? Well, internationally respected aviation academics, look at our details, that have undertaken research which has been industry focused with awareness of government needs. So we'll be seeking a partner from the technology side, technology focused with that expertise. We will be able to provide expertise in relation to policy implementation, policy implications, and public acceptance. Thank you very much.
Great, thank you very much. Next up is Clemence Rouge from FAC Technology.
Hi, good afternoon, everyone. I'm Dr. Clemence Rouge from FAC Technology. So we are a small SME based in London, and our main focus is on developing innovative and cost-effective solutions for design, manufacture, and testing of composite structures. So you have an example here of one of our development, which was about new manufacturing processes for lightweight composite panels for the base panel of ULDs. Next slide, please. So one of the projects that we also engineered is a thermally conductive adhesive, which is also structural and which is also electrically insulating. So our project idea is to use it into batteries and powertrains in order to enhance the heat transfer and to enable fast charging rates and to increase the life of the cells and the batteries. You have an example on the picture of the enhanced heat transfer that we can achieve. The adhesive being structural also means that you can reduce the weight of the assemblies because you don't need any more bolts and other parts to assemble the batteries. And one concern you may have with using a structural adhesive is that you cannot debond the parts to get from each other. Actually, we've been proven that we have bonded the battery, debonded, cleaned it, and reassembled it without eating the performance of the batteries. So what we can offer in our consortium is to integrate our thermal interface adhesive into the assembly you want to improve and tailor the adhesive properties to meet your needs. So overall, we are looking for partners that want to overcome the battery limitations that have been mentioned already several times this morning. So, thank you.
Thank you. Next up, Luke Sperrin from H2Go Power Limited.
Right, hello, everybody. My name is Luke, co-founder and CCO of H2Go Power. We were one of the successful phase 1 applicants. And at H2Go Power, we design, develop, and integrate low-pressure hydrogen storage solutions using materials that can reversibly store hydrogen gas. We cover a wide range of technical disciplines, including chemical, modelling, and product design and manufacture. You may have seen our recent BBC feature covering our solid-state hydrogen storage technology on a drone in Boston with our partners, Ballard, who develop fuel cell systems. Next slide, please. We are proposing the use of low-pressure hydrogen storage for zero-emission long-duration flight. Batteries are heavy and are limited to short flights, with the only current option for long-haul flights being polluting fossil fuels. Hydrogen is an excellent alternative, but there is concern in the industry with regards to storing hydrogen as a high-pressure gas or a low-temperature liquid. We achieve our vision through using liquid organic hydrogen carriers, LOHCs for short, by controlling hydrogen gas release through to a fuel cell. These materials have high gravimetric and volumetric energy densities, so that's ideal for flight. We'll be developing the system to power a medium-sized UAV, this is about 20 kilograms and bigger, with the intention of scaling for large aircraft. We're looking to conduct a small-scale test system within the 12 months, and that's on the drone, the medium-sized drone. We're looking for flight platforms looking to diversify their onboard powertrain and extend flight times. Also want to understand how hydrogen can be applied to specific use cases that need this extended flight time, and then what infrastructure is needed to support for these. Please get in touch if you want to learn more.
Great, thank you very much. Peter Evans from City Clipper, please.
Hi everyone, Peter Evans from City Clipper. City Clipper is a startup sub-regional airline, which we like to call a micro commuter, which has got specific focus. Hi, can you hear me?
Yep, we can hear you.
Okay, so we have a phased plan to develop the airline from use of conventional technology in the near term to electric technology. And it was founded by myself and my partner, David McRobert. I've got 35 years experience in the commercial airline industry, covering everything from long-haul international scheduled through to sub-regional operations with 8-seat single-engine turboprops. David has been involved in everything around business aviation, fixed and rotary wing, airports, pilot training, etc., etc. So we come with quite a bit of experience. Next slide, please. We've taken a phased approach to the model because we believe that we need to develop and understand what the demand is for electric flight, to develop some user acceptance ahead of the introduction of small electric aircraft, conventional takeoff and landing aircraft in the future. And so we're currently working on, as Nick and Anne said before, a minimum viable product, which we hope to launch this year, which will give us the ability to try to seek out where the demand for this product is and how acceptable it becomes for passengers to use smaller aircraft. We will then be able to give manufacturers of vehicles an opportunity for a real life test environment and work with them on identifying some valuable data points. We're looking for aircraft developers, platform manufacturers, regulators, airports, government and local authorities, user experience specialists. There've been a couple that have been mentioned today, so that we can design the end-to-end service proposition, and some data modelers and analysts who can help us assimilate various data forms into something that's usable to identify demand. Thank you.
Oh, just in time. Thank you very much. Okay, next up, Richard Ryan from Blackiston's Chambers.
Hi, Michelle, can you hear me?
Yes, I can hear you when you're ready.
Thank you very much. So yeah, my name is Richard Ryan from Blackiston's Chambers. I'm a barrister, not to be confused with barista that makes coffee. I don't do that, but what I do is give legal advice relating to drones. By way of background, I am a PFCO holder and have been for many years. And I also worked for the Civil Aviation Authority on complex drone permissions, everything from land up to space. As a disclosure point, I am also working directly for BAE Systems, and happy to talk to other partners, potential partners, in relation to work we could collaborate with on BAE Systems. The focus of this presentation is about a PhD that I'm now doing with Cranfield University, which I believe is the first in the world, looking at new drone law. Could you go to the next slide, please? So ultimately, what I want to do is develop the legal framework for UTM. And as we all know, UTM presents significant legal issues, and the regulator has got a huge responsibility in making sure that, in accordance with ICAO's principle on UTM, access to airspace should remain equitable for all. And that's where I'm coming from here. I'm also looking at local change in the law. For example, the drone bill, I think, is biased towards PFCO holders, and there's a lot of interaction between local law and state law. This is really good new legal research, which I think will make good law, making the airspace equitable for all. What I want to do is provide some case study research over the next 5 years, so that I can form and put together a framework for UTM. Partners I'm looking for are UTM platforms. Those that are wanting to engage and do complex BV loss ops would be great, and also regulators. Thank you very much.
That's great. Thank you very much. You should pitch in our regulation session next week. That'd be great if you can. Okay, next up is Roman Grzonka from Cyber Vector.
Hello, can you hear me?
Yes.
Great. Yes, we're pitching drone monitoring and control. Cyber Vector is a small SME based in the West Country. The picture we have is that conventional tracking systems, existing transmitters and receivers in urban areas in particular, will be highly pressured and with potential bottlenecks that will be attractive to cyber attack. We've got a background in developing systems that involve multi-static radar using radio frequency emitters of opportunity. We're developing a concept that makes use of RF transmitters from existing sources such as mobile 4 and 5G, DAB and more conventional transmitters that can detect and track any objects in real time in the air and on the ground in all weather. The complexity of signal processing in the kind of multi-path situations, as you can see from the visualization on the first slide, is quite formidable because of the number of power lines, birds, and a wide range of other flying objects. To kind of counter this, we've also got a background in the use of machine learning to produce algorithms that can embrace this complexity in signal processing and to get that accurate detection and tracking that's necessary. Once developed, these algorithms actually transition from high performance data crunching machine learning farm to typical desktop type computers, or the kind of platforms that are used for drones and future air vehicles. So it's not competition expensive. Now, we aim to produce very near-term benefits for air safety with this concept, especially with regard to collision avoidance and congested air environments, particularly where there's growing autonomous flight. Other benefits could include flight path optimization, with the aim of reducing energy consumption and attracting existing mobile 4 and 5G operators with new revenue streams. Just briefly show the next slide. People can actually read through that at their own pace.
Okay, thank you.
Thank you.
Next up is Richard Glassick from University of Nottingham.
Can you hear me all right?
Yeah.
Great. Yeah, so as mentioned, Richard Glassick, Research Fellow, University of Nottingham. I'm probably speaking to people who have not yet contacted, and I'm happy to share the full details of this concept if you just contact me. Can I have the next slide, please? So the question is really, why don't more regular people fly stuff? You know, it's too hard, and why? Why don't licensed private pilots fly more often? You know, it's too hard and it's too much hassle, and why? Why? Because communications, navigation, weather, that's the main deal. Like, it's actually pretty easy to fly the plane usually. At some point there'll be full automation, but when? So why don't we solve the problem using available technology that we know works to enable current pilots to fly so much easier, safer, and much more often? Why don't we use this as a basis for future increases in automation, get used to having radically increased airspace utilization? Let's turn off the clouds, turn off IMC, just fly the aircraft and see everything you need to see directly in your field of vision. Where you look is where you see, with anything you need to see displayed digitally from database or sensors in a mixed reality headset. Let's have all communications as necessary, voice only in an emergency, mostly none's needed, and navigation included like a car GPS. We don't need to have the ridiculous controlled flight into terrain and mid-air collision accidents anymore. We don't need to fly blind. We don't need the operation of an aircraft to be so highly complex. We have at Nottingham all of the facilities to do this. We're looking for a lead industrial partner. We've got mixed reality, we've got geospatial, we've got computer science, human factors. So contact me if you will.
Okay, thank you very much, Richard. Next up is John Rees from Novel Engineering Consultancy.
Thank you. Hi, I'm John Rees from Novel Engineering. We are an engineering consultancy provider in the aerospace market, focused on the design of highly complex safety critical systems and some of the training that's around that. We've built a reputation within the industry over the past few years as being one of the high niche and extremely agile businesses, with a track record of accelerating products through from very early TRL levels up to certification and production. We work with a range of clients throughout the supply chain, from component and subsystem suppliers all the way up to airframers, and we work with large multinationals such as Airbus and Mitsubishi, alongside startups as well. We're based in the UK. Our main engineering office is in the UK, but we do actually have an office in Japan as well. Next slide, please. So we're here today really to help the new entrants into the eVTOL market, and I believe we can do that through bringing our deep domain expertise in the safety and certification requirements of the aerospace market. What we can offer is that deep certification knowledge and an understanding of the requirements there, and particularly the special conditions for VTOL certification. And then the expertise in terms of the domains we have that are particularly relevant are flight control systems design, propulsion systems and electric motor design, electric actuation systems design, and they're all supported by the EME and safety, aircraft safety design capability that we have within the business. Looking to talk to eVTOL vehicle manufacturers, also really anybody in the supply chain, and also happy to partner with service providers that are looking to enter that market. Thank you.
Thank you. Okay, next up is Chris Daniels from Flarebright.
Okay, quick sound check, Michelle.
Perfect.
Great. So we believe that true autonomous flight is a global goal of aviation, and we do that autonomy. The genesis of Flarebright, where we started, is in autonomous subsea robotics. So under oceans, GPS signals don't get through, and it's almost impossible to use other comms. So we've had to work out true autonomy and self-guided autonomous software. And we've transferred this expertise from the oceans to the air and to drones. So our current product is a fully autonomous image capture nano drone, as in the schematic. So it flies without needing any piloting, any radio comms, or any GPS. But what we've realized, and why we're speaking today, is the tech and software that we've developed, which is to get autonomously from A to B in the air, is likely to have many other uses. So next slide, please. So looking to the future, we think we can be adapted for last mile safety for BVLOS operations and for pinpoint drone delivery. So we direct our gliders to an accuracy of less than a meter after 1,000 meter flight. And if all other systems reliant on GPS or comms fail, we believe we could be used as a safety measure of last resort to autonomously fly any drone to a safe location. And finally, our systems can also pinpoint delivery of any drone cargo to a defined point on the ground. So what we can offer as Flarebright, as well as the software, the machine learning and the simulation expertise, fundamentally, we've got hands-on practical experience of integrating all this software into a flying aircraft and testing and iterating it. So we would like to team up with anyone in the BVLOS domain, and in particular, we're currently looking for embedded computer vision experts because that will enhance our capability. Thank you very much.
Thanks, Chris. Okay, next up, Jonathan Smith from STFC Hartree Centre.
Hello. So the Hartree Centre is part of the Science and Technology Facilities Council, which is part of UK Research and Innovation along with Innovate UK. The Science and Technology Facilities Council looks after national infrastructure that mostly enables fundamental physical science research, supercomputing facilities, and supporting facilities like the Large Hadron Collider and the Square Kilometre Array, so the biggest of big data experiments in the world. The Hartree Centre is a bit further up the TRL level and looks to help businesses cross the kind of missing middle by adopting advanced digital technologies such as supercomputing, AI like natural language processing, machine learning, big data, etc. Next slide, please. And actually, can you just keep rolling that until all the text appears? Thanks. So most of what we do is sort of collaborative research and development, and that will be business-led challenges where someone will come to us and ask us to help them remove a bottleneck or do a proof of concept in a 3, 6, 9, 12-month timescale. Though for this challenge, we can probably offer one of the largest supercomputers in Europe for consortium to develop their surrogate models, infrastructure, use case simulations, and assist with scale up of existing solutions to those national class platforms. We've got digital assets like uncertainty quantification toolkits for engineers, which allow you to build a simulation to a predefined tolerance or accuracy. And we look after the deep national learning infrastructure on behalf of the Joint Academic Data Science Endeavour, which is available for businesses to access at cost and that sort of thing. And it's very powerful for looking at very large and complex data sets. I've written up there a few examples of the kind of projects that we're interested in getting involved with. And if any of those are areas of interest, please get in touch. Thank you.
Okay, that's great. Thank you, Jonathan. Next up is Harry Howe from DroneStream.
Thanks, Michelle. Afternoon, everyone. I'm Harry Howe, CEO of DroneStream, which is a platform that allows drone pilots to collaborate with their teams in real time. It does this by effortlessly pulling the live video stream from the drone, supported with map data and comms, and pushing it out to the DroneStream app for those team members that are perhaps on the move, and a desktop portal for those office-bound or in a control room setting. Next slide, please. We built the platform as we felt current live streaming systems for commercial drone pilots were substandard or lacking intuitive interfaces for both the viewer and the pilot. With this in mind, we built DroneStream so that the pilot can start the stream in a matter of seconds and securely stream the data to the pre-selected members of their organization. The receiving viewers will receive a push notification on the app and be taken immediately into the real-time flight video feed. Viewers at the desktop end, perhaps they're using a laptop, will also see the stream appear within the secure portal area. If turned on, the viewers will also be able to communicate with the pilot via a message board. So that's subtly overlaid on the pilot's heads-up display. At present, DroneStream is being used by police, fire, private security organizations in the US primarily and around the world. It's also been trialed by Homeland Security for its supportive use cases in the COVID-19 crisis. The system was also recently used to stream live video from a bridge survey in Cincinnati to engineers and subject matter experts all over the state. I'd just like to round off by reaching out to any consortiums that feel that this offering may benefit their service. Yeah, please feel free to get in touch. My email is harry@dronestream.app. Thank you.
That's great. Thank you, Harry. Next up is Chris Probert from the Welsh Government.
Thanks, Michelle, and good afternoon. So the preparation of feedback government people, the Welsh Government has been the devolved administration here in Wales since 1999. As an agile and well-connected organisation, our devolved areas include health, education, and notable in the context of the Future Flight Challenge, economic development, transport, and local government. Our newly established cross-government and industry team will look to provide support to and potentially be a member of a Future Flight Challenge consortia. We are experienced in working with both industry and academia in many sectors, including aerospace and aviation, and actively support inward investment and export. Our current Smart Cymru Business R&D Fund, together with our co-investments in industry-led academic research projects, result in £20 million worth of additional R&D spend per annum. Next slide, please. At this stage, we are open to hearing from individual companies or consortia about their plans. If we can see mutual benefit in developing a proposal, we will be happy to work with you to explore your project in detail. If you attended last week's infrastructure event, you will have heard speakers talk about the potential for early adoption in rural settings and the potential for future flight concepts to address societal challenges in a unique and compelling way. I think today's use case sessions have again provided yet more examples. So for many of you, Wales could provide the solution. Segregated airspace for remotely piloted aircraft systems off the coast of West Wales was the first of its kind in the world to be established, enabling full-scale testing, training, flight trials, and demonstrations. The Welsh Government owns both Cardiff Airport and the Bro-Tarthon complex, that is a mixed-use airfield and business park, and we are well connected with the owners and operators of all other airports and airfield assets in Wales. So, as we look to phase 2 of the Future Flight Challenge, we are ready to play our part in projects that can leverage our physical, government, and industry assets. Thanks very much.
Okay, thanks, Chris. There was a slight issue with your microphone there, but I think we got that in the end. So we've got 3 more pitches, so we are nearly there, just to give you a heads up. So we'll move on to Rich Connolly from Osprey Consulting Services. When you're ready, thank you.
Thank you very much. As you say, Rich Connolly, I'm the Chief Operating Officer at Osprey Consulting Services. Osprey is a specialist aviation consultancy with a wide range of capabilities in fields of safety, airspace, and both air traffic management and air systems, which we think are going to be highly relevant to the future flight concept and program. A selection of these are shown on the slide, including just 2 of a number of relevant projects. One, the delivery of the drone mid-air collision study on behalf of the Department for Transport and others, and another the safety and airspace support that we provided to Airbus on the Zephyr high altitude drone project. Next slide, please. Turning to our ideas, I'd like to outline two in particular to support use case development. The first is a safety assessment tool that we've developed called Ether. Ether supports the integration of unmanned platforms into both segregated and unsegregated airspace through a robust safety risk assessment. In terms of innovation, there's nothing else like it, and it's proven. It's a development of the concept that we prepared for Zephyr. It takes into account a wide range of factors and allows the risk of an operation to be quantified, be that during the planning phase or during the operation itself, or be it by an organization or the operator actually flying the mission. It does this through developing an operating strategy, an innovative safety assessment, and the provision of a tool that allows dynamic assessment of risk during the operation itself. The other area where we believe Osprey could significantly contribute is in the field of regulatory approval. Many of our team have a background working by our Innovation in Safety Award from the Institute of Engineering and Technology. So we're looking to support a wide community in the next phase of the Future Flight programme, be that a company or organisational level, to consortia that are developing submissions for the Future Flight concept, or even down to individual operators to support their specific activities. Please get in touch. My details are on the first slide. Thank you.
Thank you very much. And so next up is Deirdre Dirksen from AV.
Hello, Michelle, can you hear me?
Yes.
Okay, thank you. Good afternoon, everyone. My name is Diederik Derksen, and I work as a business developer within AV. AV is a drone manufacturer from the Netherlands. We are working towards a sustainable aviation for a positive impact. We are currently using our VTOL electric wing drone, which is suitable for medical delivery and first response operations. Our aircraft is designed with a focus on BFLOS flights within the EU, taking into account the new EASA regulations. We're also the technical partner of the Medical Drone Service Consortium in the Netherlands. The drone we operate within this consortium can be seen on the right. Next slide, please. We would like to join the consortium or team up with other parties that are looking into the possibilities of the following idea: delivering medical goods from and to rural areas by means of our long VTOL wing drone. With this, serving society and making positive impact by improving access to healthcare. What's innovative about it? Well, our payload is capable of maintaining the cold chain through the sky. Timely deliveries independent of traffic allow for centralized storage, lower cost and less waste. The service we can offer, our electric VTOL long-range wing drone, experience working with healthcare providers, logistic operators, regulators, municipalities for medical drone deliveries, know-how of BFLOS drones operations within the EU, and gathering approval and public acceptance. The partners we would be interested in or we would like to collaborate with are healthcare providers or partners, drone operators, logistic partners. If you're interested, let's get in touch during this afternoon's one-on-one meeting or have a look on our website, av.eu. Thank you.
Thank you. Next up is Farah Hashim at Samad Aerospace.
Hello, Michelle.
Hello.
Hi, everyone. This is Farah from Samad Aerospace. Samad Aerospace is an SME which develops a range of vertical takeoff and landing hybrid electric aircraft, eVTOLs. Our Starling fleet, both manned and unmanned, are exclusively aimed for civil aviation missions, emergency medical services, police patrols, and others, all needing to travel point to point by air faster without the need of an airport at minimal financial and environmental costs. We are the only technology company that takes existing air travel experience to the next level by delivering safe, fast, efficient, green, and comfortable air travel experience. Next slide, if you please. Our project for phase 2 future flight is called MED-EVOLUTE, which stands for Medical eVTOL Light Interurban Transportation System. Develop a roadmap to integrate a smart, green, and efficient air transport for emergency medical services, delivering both medical personnel. What's innovative about it? Well, it's the mission itself, where we look into medical drone deliveries to deliver test samples or results and vital transport organs between cities, and also transferring critical care paramedics to injured patients at remote locations to provide the emergency treatment and stabilize them before they can be transported to a medical setting for further treatment. We get the help there fast, whenever and wherever it's needed, and every second counts. So we are a technology provider. We have designed our starting aircraft in collaboration with Cranfield Uni. We built successful scaled prototypes. All of them have undergone successful ground and flight tests. We offer solution development, design and build a bespoke eVTOL aircraft utilizing our existing technology capability. We're looking for partners for various key stakeholders, include medical services operator and customers, digital and physical infrastructure, medical packaging, UTM, ATM, including BVLOS, certification bodies, and also bodies that cover social acceptance and market readiness of such integrated system of systems. We have a number of partners with us, so still open. So if you're interested and feel you can contribute to the MED-EVOLUTE project with us in any way, we'd like to hear from you. Thank you.
Okay, that's great. Thank you very much. Do we have any more that have come in? Annelise.
Yes, hi, good morning.
Hi.
Can you hear me?
Yes, I can hear you.
Good morning, Annelise of the Drone Office, and representing a team selected for Future Flight Phase 1 for our medical drone delivery project. Our objective is to develop the operational framework and then implement it through direct engagement with end users and local communities. We want to deliver a viable solution to a real unmet need, engagement and acceptance by healthcare practitioners and local communities on the ground, and of course, strict compliance with both medical and aerospace safety and security requirements. We are a complementary team combining medical and drone background, as you can see in the top left box of the slide. Our capabilities are the development of evidence-based use cases anchored in real life. For example, Paul Royal of King's College London, who should be on the call, has been working on drone delivery of medicines in emergency situations in the north of England, as well as the delivery of therapies directly to patients. Intelsius provided the temperature control packaging for the UNICEF vaccine delivery project in Vanuatu. Since we've been in contact with a number of health organizations, especially lately in the current crisis. For phase 2, our approach is to join broader consortium. We are already working with a few complementary teams. We are open to further discussions to the extent that the projects can work out and be complementary using different use cases. Also, the feedback we get from the community of end users is that they would like to benefit from the sharing of their learnings and of the experiences, so that possibly, cross-referencing or organizing the sharing of knowledge among end users could be a valuable input. Thank you.
That's great. Thanks, Annelise. Okay, next up is Paul Topping, Animal Robotics.
Hi, I'm Paul Topping from Animal Dynamics. We're a 5-year-old 70-person company that came from the Oxford University Zoology Department. We have a number of different autonomous flying drones with civilian and defense use. I'd like to show you a particular family on the next page. So this is our Stork series of drones. They have parafoil wings. They are very robust. They are extremely efficient in flight, hence the Stork moniker. And we have 2 different versions. There's an ST25, which has a 25 kilo takeoff weight, and there's an STM, which is affectionately known in the company as the flying shopping trolley, because it can carry 135 kilos. They both fly autonomously, and they can be electrically or internally combustion propelled. They are particularly efficient in flight, so electric propulsion does make sense. The ST-25 is, as you can see from the picture, at a fairly high level of readiness. The STM is currently in development, but we do have prototype versions, and we're interested in talking to anyone that can either help us with components of these or actually use them from a logistic point of view. Thanks very much.
Okay, that's great. Thank you very much. Apologies for that. My printer seemed to have printed the first page only, and I didn't realise there was 2 at the end, so apologies for that. Okay, well, that brings us to the end of the pitches, and essentially we can close off this today's session. I just wanted to highlight to you something that we're going to be running through with KTN is to support new collaborations and exchange of knowledge and expertise. We're going to be running some monthly webinars, and on a Friday at 12 p.m. and there'll only be a maximum of about 40 minutes, and hopefully aiming for around half an hour. And it's just a call to action, really, an invitation. Perhaps if you're wanting to apply into phase 2 and subsequent want to get involved in future flight, it's an opportunity to give a bit more of an extended presentation, 10 minutes. There's something to think about. You can contact us at Future Flight, email address there, and pick one of those Fridays. We will probably aim to have a couple of speakers, probably at the most, so that we can leave some time for questions. So if you're interested in that, please touch base. We're interested in anyone that's obviously wanting to build a consortia, phase 2 and 3, and also if you've got some capability that you think will be useful as well. So I'll leave that with you, and I guess I just want to thank all the speakers today. I think it's been quite a really good session today, and hopefully next week we will overcome these technology glitches, and I hope you enjoyed the session. I hope your meetings are useful, so thank you very much and goodbye.
We need to be bringing together people with expertise in airspace management, airframe manufacturers, artificial intelligence expertise, and also it's about the infrastructure, the digital and physical infrastructure that are required in order to deliver this future aviation system. KTN is very well placed in order to bring all these different stakeholders together.
We're going to have to adopt innovative and new ways of moving people around. So this is a really good opportunity to get the really good ideas that are out there about different ways of delivering that aviation infrastructure.
We in the UK have an awful lot of talent that the UK is invested in, and we are pulling this all together. So lots of different technologies, lots of different facilities, and lots of people from many different disciplines. And we are going to create a next generation capability that is greater than the sum of its parts. That is so exciting.
The challenge is working as an enabler for the future generations, not just for myself, my children's children and beyond, and how we're going to impact things on much a grander scale than we can even imagine. And we're bringing together so many different businesses, industries and areas of technology that we didn't even think would need to work together, creating a new story for us all. So that's really exciting.
For me, the most exciting aspect of the Future Flight Challenge is the opportunity to bring together a diverse range of innovators, people who wouldn't normally talk to each other across many different industrial sectors, and to get them to work together towards our overall objective.
The single biggest hurdle that needs to be overcome is getting the right people to be working together, which I think the Future Flight programme is admirably making an effort to do. The technical and engineering expertise in the UK makes us very well positioned to take an international lead in this space.
The most exciting dimension of the Future Flight Challenge for me
is learning about the new technology, but also providing a user case to many of the people that I've met here, because I'm very interested in using drones to deliver medicines. And the thing that really excites me is the ability to precisely deliver something, but also to deliver that in a timely and safe manner.
So the most exciting dimension of the Future Flight Challenge is probably by far the scale of the program, the breadth of innovation that it brings together, and the fact it brings really the best of innovation in the UK all together.
The approach that we've taken in Future Flight, and one of the things that we see as quite challenging, is we've not pre-decided which future aircraft is the right solution. We've kind of left ours quite open and said the types of aircraft, the timing of them and how they fit together, we're open-minded about. So for us, there's a great degree of innovation and some risk involved in saying we don't know the answer, we're going to be very broad-based, we're going to support people across that spectrum, and we'll kind of see what emerges. So there is a little bit of we try things, we learn and we move on, rather than have a really prescribed programme.